right, welcome to the Soil Health Results Workshop. This is phase 4 of a soil health project we started back over a year ago now, a year and a half ago. So we wanted everybody to come together and go over results, as is in the title. But we made this possible so everybody could come, and because there's lots to learn with soil results. So the funding that made this project in total possible was the Nova Scotia Climate Change Plan for Clean Growth. So they've funded this, and this has been a big help to get all these soil samples and everything collected and people hired to get those done. But for this workshop, we partner with OFCAF and Perennia to make this more enjoyable for everybody, so everybody could come and enjoy themselves while we just talk a little bit about a few things all in one day. So today we're going to talk about soil health tests explained by Caitlin. Caitlin couldn't be here today, but she's going to be online. So we had to adjust a little bit, so she's going to present right away. We're going to talk about biological nitrogen availability test. Amy's going to be talking about that after, then we're going to lunch. And then we're going to have our keynote speaker, Ryan Barrett from PEI, come up and deliver a presentation for us. And then we're going to have a grower panel and talk about practices to improve soil health and how we can do that and just get some good knowledge transfer in between all our farmers here. So just a little bit, I just want to recap quickly about the soil health project. I'm going to see if this is going to, it is. There's a little video I put together just from the beginning to the end. We went out to 117 meters of field and sampled. We took the samples of each field, and we sent these samples to two different labs. So one PEI and one in the Windsor. And this is what the soil lab got a tour with. Some of the work that we did for this project. And we did this between September and November. We had each of our horticulture members sign up, register, and we went out to their farms, collected the samples, and then got them to the lab. And now we're here today to go over what the soil results mean and where we go from here. So just quickly about the testing that we did. PEI, we did more of the soil health focus, so soil respiration, aggregate stability, available water capacity, and active carbon. And then Nova Scotia Lab did the standard S1 chemical analysis package, and the new biological nitrogen availability test that they're going to be hopefully offering in Nova Scotia. And Amy's going to be talking about that more in depth a little later. And to make this all possible, what kind of how we started was we were asking ourselves, what do farmers know what's in their soil health? Like, do horticulture farmers really know what's in their soil? But what if they did? What if they did know? And how would that change production? And how would that change the practices? So I started by talking with Amy at our horticulture conference last year, and like, hey, what could we do? And she's like, I have some ideas. And so we developed a little team with Amy, her lab, Caitlin from Perennia, and then both of their knowledge and their support has been amazing through this. And then we had Stuart come on a little bit later with Perennia, and he had some ideas. And then we also had Chris Ross from the Department of Ag, and his technology and soil data collection was extremely helpful to get all of this running smoothly. And I'm actually gonna get Chris, if he could come up and just talk a little bit about the 2 links that that he's provided for me today. So what we did was we gathered this data, talked to Chris, what can you do? He's like, well, we can do some mapping, we can show a bit of a picture on what we've done. So, all right, we got it working? Okay, Chris, maybe you want to just quickly explain what we're looking at, and you can help us out with that.
Thanks, Cheryl. All right, morning everyone. My name is Chris Ross. I work with the Department of Agriculture. Our team really kind of houses a lot of the GIS or geomatics expertise within the department. When Cheryl and Amy kind of brought this project forward, we thought this would be a great opportunity to see how we can kind of leverage more current technology to help, track, collect information, and then try and consolidate it. So the big thing, as you're aware, is when we go out, we take our soil samples, we get them submitted, we get those results back. We're looking at typically a piece of paper, and you as farmers and individuals that manage those fields, a lot of that information in your head, but it's nice to have that picture or that interface on the ground, so you kind of make the connection there of, oh, these are actually what the representative area for these soil samples are. This is what was grown last year, and then especially as you expand, say if you're looking at, in this case, hundreds of samples, to try and make that connection there. So what we did is, we're always interested in trying to utilize information, make it accessible. So we thought this would be a great opportunity. Typically, in the past, when we go out and take soil samples, everything's recorded on paper. So the first thing we did is we made kind of a digital form that's accessible on your phone. You go out and fill that information out, captures everything critical there. And then once the analysis is done, we have that data back. What we tried to do in this case was make it all accessible kind of in a mapping interface. So this is just an example. When Cheryl and Ariana, I believe her name is, went out and collected that information, they took pictures of different areas. They captured this information. And we basically just consolidated it into a larger mapping system here. So the real valuable thing is when we look at everything collectively, is we can kind of map everything across all of the projects. So all 117 fields, we kind of looked at all of those samples, and we can actually add and overlay more information. So whether it be drainage insight, historical soil information. So the big thing for us from the department side is we're trying to say, how do we utilize that information better? How do we get a better picture of our soils through time in the future? And then as we add more insights and gain it from the data to make that accessible. So for reference, this is just an example. Obviously, it's not something that's offered per se right now to folks, but as we kind of move forward in the future, we want to try and make better use of that data, make it more accessible, and gain further insight. So I'll leave it here. We can maybe take a peek later on if we have some more time, maybe even over lunch, but really great opportunity in terms of visualizing that information and making those connections to your soil and soil data accordingly. So I'll pass it back over to Cheryl.
Great, thanks, Chris. I figured a good visual would be really good for everyone to see what actually is done, rather than just the piece of paper and all the cool pictures and polygons we can stare at. I don't know, memorized by watching it, but okay. Now what we're gonna do is we're going to get back and get Caitlin online, and Caitlin's gonna go over the results, and she's gonna do a little presentation for us here. So, the speaker is gonna be coming out of the projector, so we might have to be a little bit, open your ears. Actually, I can put the mic over there. Let's try that. Okay, Caitlin.
Okay. Do you need me to talk really loudly?
Can we do that? Yes.
We got this. There we go, Caitlin. It's all yours.
Okay, awesome. Can people see my face as well, or just the slides?
We can see your face.
Both.
Oh, okay, great. Well, first, I'm sorry that I'm not there in person, but if you saw me yesterday, you'd be very happy that I'm not there in person. I know that Cheryl did a little introduction, so I'm just going to start off the talks with just talking about soil health in general and some things that are on the soil health test. I know a lot of people there are probably familiar with it, but if you're not, just I can't see anybody, so if they have questions, just let me know, Cheryl. So before I get into the actual soil health test, I just kind of want to go briefly over what is soil health. And one important thing about the definition of soil health is that it's not a uniform definition because it can change based on the conditions, it can change based on who's giving the definition. One that's commonly used is the capacity of a soil to function within ecosystems and land use boundaries to sustain biological productivity, environmental quality, and plant, animal, and human health. So this is the definition in the Digging into Canadian Soils textbook that's available online if you ever want a free resource just about general soil stuff. That's a great place to start. Another important thing about soil health is that it encompasses the physical, chemical, and biological properties of the soil. So no one measurement can encompass soil health. And so that's where the soil health test comes into play. Because the soils are so complex, one measurement or even two or three aren't enough to really capture the overall health. Similar to human health, doing one test might give you some indication that you are unhealthy, but it might not give you an overall indication of your health. So the soil health test will look at multiple measurements, and some of them are direct measurements of different soil properties, and some of them are indicators of soil function. And so one important thing that I want you to keep in mind as we talk about the different things on a soil health test is that soil health also looks different across ecosystems and cropping systems. Same as human health, what's healthy for one person may be different than somebody else. So your soil health test may look different than your neighbor's, but it's really going to depend on what your site conditions are, what your management is, and what cropping systems you're working with. So I'm just going to do a very, very brief history of the soil health test. So in the mid-20th century, it was really focused on chemical properties, and a lot of soil tests are still very focused on these properties. So pH, nutrients, and it was mainly developed for agriculture productivity. As the 20th century wore on, they started incorporating physical soil properties like soil texture, soil structure that play a role particularly with water management. And then now there's kind of a shift towards looking at this more soil biology and looking at the whole suite of soil health parameters rather than just a few. And this is when the development of the Cornell soil health test occurred and other soil tests. Okay. So as we move on looking at this soil health, and I know that those of you who are involved in this project, this is kind of where you're heading. We're looking at increasing improvement of biological indicators because right now a lot of the biological indicators we have, the information that they provide us are still quite limited. There's a movement towards a focus on carbon sequestration and sustainability as opposed to direct just focus on productivity. And there's also movement towards standardized testing in different regions. So the PEI soil health test has a suite of different properties I think many of you probably have seen one, but it was originally adapted from the Cornell Soil Health Assessment. And so this is a list of all of the different things that can be evaluated on the soil health assessment. And so what typically has been done in PEI and other places that have used this as a baseline for their soil health assessment is they've taken the different properties that they think are most valuable to their region. And so the PEI soil health test includes these different properties. And so a lot of the chemical ones are ones that are on the regular soil health test. So I'm not going to, the standard soil test that you can get at the provincial lab. I'm not going to touch on a lot of that stuff today. I'm going to mainly focus on the things that are not on that test. So the lab also has, so in green here are the ones that are on the standard soil lab. So we're going to focus on these other 6 or 7 properties that are on the soil health test. And what I'd like to focus on with these is we'll briefly go through them, and I'm only going to talk for about 20-25 minutes and talk about what they mean, what is a potential interpretation, and what potential recommendations can come from these results. Again, as we go through these tests, keep in mind that the recommendations, especially for Nova Scotia, aren't that robust yet because we don't have the amount of samples we need to make these interpretations. But as part of this project that lots of you are involved in, that's where I think we're hoping to move to. So the soil health test report looks like this. So I think some of these will probably be quite small, but we can zoom in on a few of these properties. And so the first thing on there is your soil texture. So soil texture refers to the relative abundance of sand, silt, and clay in soil, where clay has the smallest particle size and sand has the largest. So the important thing about texture is that it cannot be directly changed, and it gives an indication of your nutrient retention and your drainage in your soil. So these are 2 very important things when it comes to soil health. Now, most agriculture producers have an idea of what their texture is. They know, okay, I have a loam or a sandy loam, but what the soil health test provides you is just a little bit more detail. So it does a test to understand the exact percentage of sand, silt, and clay in your soil. And then you can look at over here with the texture triangle where that fits within the different potential soils. And you can use that information to make decisions for water management on your farm, as well as understand what your potential for leaching of nutrients is. So the big thing there is it just provides a little bit more detail about your texture. So the next thing on the soil health test is active carbon. So the next thing is organic matter. I decided not to talk at length about organic matter because it's on the regular soil test, but organic matter is an extremely important part of your soil health. But the next thing that's on there is active carbon. So we typically measure carbon using the soil organic matter. So that gives us an indication of how much soil organic carbon is in your soil. But typically the organic matter can range from 50 to 60% organic carbon. However, with these different pools of carbon, which I'll show on the next slide, it often takes a long time to see changes in soil carbon. So this is just an example here of looking at organic carbon. And we think about organic carbon sometimes in the context of carbon sequestration. So you have your inputs like plant residues, photosynthesis, manure, and compost, and your outputs such as respiration, decomposition, harvest, and erosion. And so to simplify carbon sequestration, basically if your outputs outweigh your inputs, you will have a loss of that organic carbon. And if your inputs outweigh your outputs, you'll have a gain of that organic carbon in your soil. However, because this is so difficult to measure sometimes, we can look at active carbon. So the soil organic matter measurement is the overall organic matter in your soil, and it can take a long time to change. But you have these different pools of carbon that exist. So this active pool here, and then you have more physically and chemically protected soil carbon, and then really stable carbon. So that really stable carbon is very difficult to see changes in a short amount of time. So that's why we measure active carbon, because you can potentially see changes within 1 to 5 years, and it is the most responsive to changes in management. So this active pool consists of decomposing plants, residues, and microbial biomass. It's more dynamic, so it changes more rapidly. So basically, your microbes need to eat, and they get their energy from their carbon, and it's their source of food for the microbial community. So that's where a lot of this turnover is happening, and you'll see these changes. So in the Cornell soil health test, it often says that, and even on the PEI soil lab, it'll say more is better. So a lot of these measurements, you either have more is better, less is better, or a range. And so active carbon is really important because it's involved in the formation of aggregates. It's useful for evaluating the impact of management on your soil organic matter. So if you have a change in tillage regime, you might see this in the active carbon. And it gives an indication of the biological community. So typically more is better, but excessive microbial activity can lead to rapid decomposition and potentially deplete the stable organic matter. So yes, more is better, but if there is excessive microbial activity in that active carbon, it can lead to higher rates of microbial immobilization, so such as, and making things like nitrogen and stuff less available to your plants. And again, this depends on your cropping system. So something that requires a lot more tillage the active carbon is going to look a lot different. So how do you increase active carbon? Much like a lot of these soil properties measured on the soil health test, increasing soil organic matter is one of the key recommendations to increasing active carbon. So if you reduce practices that are decreasing soil organic matter, or do practices such as cover cropping or applying organic amendments, can potentially increase this active carbon. So I've seen ranges between 200 and 700 micrograms per gram of active carbon. This table here gives an indication of different cropping types and where you want to be for, low, medium to high. This is specifically for PEI, and it may not include some of the cropping systems that you have. So I decided to spend a little bit more time on active carbon because it is one of the more complicated measurements of the soil health test. And the next one that's on the soil health test is, again, a microbial or soil biology indicator, and that's soil respiration. So believe it or not, soils do breathe, and microbes and roots in the soil can respire and release CO2. So same as humans, the more active you are, the more you're going to breathe, and so the more CO2 is being emitted. So measuring soil respiration is an indicator of microbial activity. So it can indicate abundance and activity, but not necessarily tell you if you have more bacteria versus fungi or what's going on in that respect. It just gives you an overall indication of abundance and activity. So diversity is not included in this measurement. So this means that it can give you an indication of your soil's capacity to mineralize residues and convert them to nutrients. So you need those microbes working to be able to mineralize nutrients for your plants. And so this gives you an indication of that. Again, the soil health test does say that more is better. So how we want to increase this is, again, by increasing your soil organic matter. So you want to make a comfortable home for your microbial community, and that resides in your soil organic matter. So here are the measurements here for the PEI. Gives you a bit of an indication of the range that you want to be in. But again, overall, more is better. But if you have really, really high activity, again, you can have a lot of CO2 being emitted from your soil. So the next one is aggregate stability. And I do love talking about aggregate stability. And so basically, aggregates form and naturally in soil, so there's naturally forming clumps of soil, and they form through chemical bonds, the formation of biological glues from bacteria and fungi, and then also physical roots and fungal hyphae can hold these aggregates together even more. So these aggregates form, but the aggregate stability refers to the ability of the soil to resist breaking apart when forces are applied, such as compaction or rainfall. And so stable aggregates help promote carbon sequestration, good drainage, and good structure. And so here is just some examples of some different aggregates that I've found through digging pits. And so you can see kind of, you often want a combination of different aggregate sizes, but you want them to be able to be kind of often referred to as like a cottage cheese texture, where you're able, water and nutrients are able to move through the soil, but not at an increasingly rapid pace, such as if you have single grain soil like sand, where water would move right through. Or if you have something that is a little bit more compacted, then water might sit on top, and roots may not be able to penetrate through. So aggregate formation and aggregate stability is very important. So this is one, again, more is better, typically. And so it's measured as a percentage. And so the percentage basically, at the PEI's Soil Lab, they use a rainfall simulator. And basically they measure how much of those aggregates stay together underneath those conditions. So the higher the aggregate stability means that your soil will be less likely to fall apart. And so they use a rainfall simulator, but make sure to keep in mind that there are other things that can make your soil fall apart, as opposed, not just rainfall. Again, here's the table that represents the PEI, different crops within PEI, and so really you want your aggregate stability to be, greater than that kind of 50%. But again, we don't have these numbers, particularly for Nova Scotia yet. The next one is biological nitrogen availability, and so this was a test that was developed by the Soil Lab in Truro, and I know that Amy is going to talk about this a little bit more, so I'm not going to go into too many details here. But the big thing is that when you look at your soil, your standard soil test from the lab, you know that you don't get a nitrogen measurement. And typically when we do nitrogen management, we work backwards. So you have kind of what you want your crop to have, and then you work backwards from your nitrogen credits, such as if you're applying manure, or if you have nitrogen fixing cover crops, you can reduce the amount of nitrogen that you need. So the thought around this test is that this can be an additional credit. And so what it does is captures the potentially mineralizable nitrogen. So this is the nitrogen that's converted from organic to inorganic forms. And so they do a 2-week incubation test to measure how much nitrogen will be mineralized in that soil. And so just to give you a little bit more context, this is the nitrogen cycle in soil. So you have your organic matter pool here, and then your mineralization into a plant available form, such as ammonium and then through to nitrate, is what you're trying to capture here, so that you're getting credit for the nitrogen that's in your organic matter. So biological nitrogen activity has a relationship with soil organic matter. And so if you want to increase your biological nitrogen activity, you can increase your soil organic matter. And you want to promote conditions which are favorable to those bacteria who perform mineralization, so such as good aeration and good drainage. And again, this gives you a little bit of context of what these numbers look like. So it's measured in milligrams per kilogram. And so here, kind of anything over 30 or 45, depending on the cropping system, is considered high. But again, these are values for PEI. So I think the last one I'm going to touch on that's not on the standard soil health test is the phosphorus index. So we do measure phosphorus on the soil health test, or on the standard soil test, right? However, it measures the available phosphorus, but phosphorus is quite finicky, and it can bind with it can fix or bind with different like hydrous oxides or iron, manganese, and at high pHs it can fix with calcium. So sometimes it's not always as available as we think, and it is very pH dependent. So this shows here kind of the relatively available phosphate that would be available to your plant, and on a scale from 1 to 100, so percentage scale here, that's really not that high. So the phosphorus index gives a little bit more of an indication of what phosphorus is actually available. So it measures a nutrient ratio with aluminum. So aluminum is an element that can cause severe damage to roots. And aluminum is more available at low pHs. So it's trying to take in that extra element into account when measuring your phosphorus availability. So it gives a better indication of the amount of phosphorus available in your soil. And so this is what the standard test, the PEI test says. So it's measured as a percentage. If your pH is less than 5.5, you want your phosphorus index to be about 19%, and if it's greater than 5.5, it's 14. So it's very dependent on your pH. So in order to increase this, you can increase the phosphorus in your soil and promote the availability of phosphorus. So managing your soil pH is very important here, and reducing compaction. So the last one I think that's on the soil health test is available water capacity. So this is an indicator of the soil's ability to retain water. It's impacted by soil texture, structure, bulk density, and organic matter. And so basically the test applies specific pressure at water-saturated soil and at field capacity. And so here is just kind of a general, you would have sand or silt loam or a clay. You have your unavailable water up until your permanent wilting point, and then field capacity here. So this in green is where your plant available water comes from. And so this is going to change based on your texture. So again, what your available water capacity may look very different than your neighbors depending on your soil type. So the thing is, though, is we cannot change texture. However, we can promote improvements in soil structure and soil organic matter, which help retain water in the soil. These are some pictures from, I think this was post-Fiona. Some of these pictures were from this one, and then this is a picture from the floods that we had 2 years ago. But basically, if you have very low available water capacity, you want to try and improve your soil aggregation and soil organic matter, which will help absorb and maintain that water in the soil. Ooh, I keep saying the last one, but this is, I think, the last one, the C to N ratio. So this gives a better indication of the relative abundance of C and N in the soil. So on your standard soil test report, you have your organic matter, which gives an indication of your carbon, and we don't measure nitrogen directly. So microbes use carbon as fuel. So if the C to N ratio is high, so you have more carbon than nitrogen, microbes can tie up nitrogen and or cause immobilization, making it less available for plants. If the C to N ratio is low, nitrogen could be potentially leached from the system. So if you have a lot more nitrogen than carbon, and typically the ideal ratio is that 20 to 1, 30 to 1. So if we go back to the nitrogen cycle here we have microbial uptake. Another word for it is immobilization. But that C to N ratio can give you an indication of whether or not your plant available nitrogen is being immobilized and becoming less plant available to your plants. So I hope that you took away something from that. Again, I apologize that I can't be there today, but I just wanted to go over the description of what is on that soil health test. So when you get those results back, you have a general idea of what it means and how you can potentially improve it. So I want to reiterate this one more time, but soil health will look different for everybody depending on your cropping system, site conditions, and management goals. More is often better, but it's not always better, and make sure that you know kind of the limitations of your system. So for a more simple example of this, organic matter is commonly looked at as more is better, but sometimes in systems like orchards and vineyards, you don't want really, really high organic matter because it can tie up some of those other products that you're applying. And so when you look at your soil health test, as we kind of move along in this process and with this project, you can use it as a baseline for your production system and take the measurements maybe every 3 to 5 years, and they would give you an indication of if your soil health is improving. And the more information that we can gain from the soil health across Nova Scotia, then the better idea we can have and give more robust recommendations based on those tests, similar to what they have in PEI. Yeah, so if you have any question, I guess I didn't really introduce myself, but yeah, I'm sure there's people in the room that I've met, but I was the former soil specialist with Perennia. I'm currently working on my PhD right now. But if you have any questions, please ask, or if you have any anything you think of later, you can contact me at either of these emails.
Great, thanks, Caitlin. Does anybody have any questions for Caitlin before we move along? Any questions? Pretty quiet, Caitlin. No? Okay, thanks, Caitlin. I think the one point I got from this was increase your soil health by organic matter, right?
Yeah, organic matter is, and a lot of research that's been going on has kind of reinforced that the soil organic is important.
Awesome. Great. Thanks so much. Thanks for coming in and doing this online. You rest up.
Could be the reason.
Bye. Okay. We did it. I don't know how you're feeling. My day's getting better. Okay, so next we're going to have Amy Sangster from the Nova Scotia Department of Agriculture with the, what do you call it, Animal and Soil Lab? Animal and Plant Lab. So let me just pull hers up here. And Amy's going to talk to you guys about the biological nitrogen availability test that Caitlin had talked about. Is this the first? Okay. And this and the clicker. I wonder if we can get it.
opportunity to be a part of this project. Before I get started, I just also want to introduce two very important people to me who are sitting at the back, and I didn't know I was going to put them on the spot. But Jody Dodge is ducking down behind his chair there. This is Jody Dodge, who works with us at the lab, and Laurie Scott as well. Jody did the bulk of the work actually on this test, this BNA test. So the results you got were largely attributed to a lot of the work that Jody had done, and he's a technician at our lab, and Laurie is our technical lab operations supervisor, and she also is really instrumental in the results of the lab. In fact, if you get your reports back and you look at who signed off on it, probably 99.9% of the time is Laurie's name on there. About 0.1% of the time I get to sign off on them, and every time I do I feel really important. So Laurie approves and does a lot of the validation as well of our reports, and is a really key part of our quality assurance system. So just wanted to acknowledge the both of them, and I'm really glad they can be here with me today. Any really tough questions I'm going to direct to them, so I'm glad they're here with me today. Yeah, this was a really fun project actually for us to be involved in, and this is something I've certainly thought about quite a bit probably over the last 20, 25 years. It's really the question of how much nitrogen is my soil making? And I'm going to take the next probably 20, 25 minutes to try and work through this problem, I guess, or this question. And as Caitlin had alluded to, I'll be talking about the biological nitrogen availability. And I'm going to do a deep dive into this, so bear with me through part of it, because we are going to kind of walk through a couple of calculations, because I do want you to understand where this has come from, and the amount of work, I guess, that's gone behind this in order to kind of get to this point. Just recently I was at a workshop, and a farmer had piped up in part of the program and said, why don't we have, after all these years of research, a good test for nitrogen? Kind of like, get with the program, what's the slowdown here? But I hope if I can do anything today is really impress upon you that this was not work that's been done in the last year. It's really a body of work that's probably encompassed in this area maybe 20 years of research by a number of different groups and researchers. So I don't want to give you the impression that this is kind of a stick a probe in the ground and we get an answer, because certainly there's a lot that goes behind this. And I think also it's important to remember that this is a work in progress. So 5 years from now, you may see what I'm presenting has changed, and it doesn't mean that today is not good, what we have. It just means that we're going to I hope that we're going to make advances and continue to make improvements on this, because I do think it's important. So my subtitle is from the biological nitrogen availability test, and that is a tongue twister for me, so I'm going to call it the BNA test from here on in, to nitrogen credits. And I think this is, from my point of view, was the kind of key change, I guess, which really made me hopeful that we could get to a point where we could have a test that you'd find very useful for your farm. And as our lab, I think this was the point in which I thought, okay, I think we should try and adopt this test and see if we can offer it. I'm hoping this is going to feel a little less like a presentation and more like a conversation, because I really do want some feedback from you. We brought this test on for you. We brought this test on to hopefully give you some more information on your farm so you can make some better management decisions. So if by the end of my presentation you're thinking, I don't think I'm going to use this, please let me know, because we will take that into consideration. Maybe just do it kindly, because Jody has put a lot of work into this, and so I'd like to see it go forward. But I do certainly want some feedback from you, and if there's a way in which we can make this more usable, or if there's extra information, or if there's some more work that needs to be done, I'd like to hear that for sure. So the whole point of this is to, and I'll just say this before I get into my presentation, Caitlin touched on the BNA test, and my, I think, frustration with some of the soil health testing is that it always seemed like you got a report back and there were some different color indicators on it, and it was kind of like, hey, you're doing a good job, or yeah, you're not. And from that, I found it really difficult to kind of discern, well, what exactly am I supposed to do with that? So yeah, I might know I'm doing a little bit better than my neighbor, maybe, I don't know. But what does that mean? Should I do no-till? Should I reduce my fertilizer? Should I try and apply some organic matter? And often the recommendations I felt were kind of akin to, eat well and get more sleep. So it's kind of things you should probably be doing already, but it didn't kind of point to a very specific management practice. And so what I'm going to present today is a little bit different, because we're going to take that soil health measurement, which is a BNA test, which isn't new, but what is kind of new is the application of it in order to give you a nitrogen credit. So that's the new part, and I think that's the part that's kind of exciting. So what's interesting is I hate this slide, and I always have. And every time someone talks about nitrogen, they throw out the nitrogen cycle slide, and it's the worst way to talk about a really dynamic process in soil is to put it in 2 dimensions and have this static kind of image on a screen, and it really does a disservice to the complexity of this cycle. Rosie had mentioned she was going to do an interpretive dance to try and describe this with some tennis balls, so I'm looking forward to that. But the point being is this cycle is so complex, and it's affected by so many factors that we don't have control over, like climate. Any kind of new weather event that happens can affect this cycle. And then, of course, a lot of your inherent soil properties are going to affect this cycle too. So these transformations in the soil are happening at different rates. They're affected by a number of external factors, and it's incredibly complex. And this is the reason why it's been such a challenge to get a test that with any kind of certainty can give you any indication about potentially what's happening in your soil. So when you see this, I hope you feel the pain I feel when you see this come up on the screen, knowing that this by no means does service this whole complex system that's happening in your soil. So the question then really becomes, can we measure soil nitrogen supply? And you're going to see on my slides, I'm flipping between Department of Agriculture slides and Dalhousie University slides. Cheryl mentioned that we had a conversation at Hort Congress a little while ago, and kudos to Cheryl for taking on a very ambitious project, and being able to pull this together, because I know there's a lot of work that went into it. But what worked out really well is it also coincided with the project that we had with Dalhousie University. So we do have a 5-year contribution agreement with Dalhousie University, and one of the outcomes of that contribution agreement was to try to look at perhaps adapting or adopting different soil measurement tools that would be of use to you as farmers. And one of these tools was looking at this kind of nitrogen BNA test and consequently a credit. So it aligned really well with some work that we had just started. And then what this project enabled us to do is put some pressure on us to get results back before this workshop, which I think we managed to do just under the wire. So we really appreciate you guys sending your samples in to us, and for those of you that participated in this project, those samples meant a lot to us, because it meant that we could run our first set of real samples for real clients, and as I say, we're hoping to get some feedback from you, from those of you that participated in the project. But I think the challenge here is trying to give a credit for the nitrogen that's in your soil. Traditionally, as Caitlin had mentioned, soil organic matter is kind of a driver of a lot of these processes. So what we've done is we've said, okay, if you have, 3.5% organic matter in your soil, we'll give you a credit of maybe, 15 kilograms per hectare of nitrogen. Let's maybe do that. And that in itself even wasn't being used all the time when we were doing nutrient management planning. And I know that because I was doing some nutrient management planning and I wasn't using that. So it's like, well, how can we possibly get a credit for what you've got in the soil where these really complex processes and transformations that are happening all the time? So that's one piece of it. So that's the BNA test. Then the other piece of this, can we measure soil nitrogen supply, of course, is any other credits you might have from perhaps like a plow down of a cover crop, or any cover crop residue that's being incorporated into your soil for that growing season, as well as any kind of manure or organic kind of amendments that are being put on. So these things collectively really feed into your growing season and mineralization, which then result in your soil nitrogen supply. But the thing is, they're affected by a number of other functions, and they're affected by water function, temperature function, and other trigger functions. And a lot of this work, I have to point out, was done over a course of many years by Rompre et al. And so as I go through this, you'll see what this group of researchers and scientists tried to do to quantify a value again for what's in your soil. And so what I'm going to do is I'm going to take you right into the lab right now and show you kind of what happens to your soil, your actual soil once we get it. And Jody would probably be better at explaining this than I would, but he's shaking his head, so I'll go with it. Thanks. So when you deliver your soil test box to us, we take some of that soil, and with this particular test, so this is the BNA test, we'll take a certain amount and we put it in that funnel, and we'll leach it and get kind of a first leaching, and we'll measure how much nitrogen is in that first leaching. A couple of interesting things to note with this test is this is done on dry soil. So we'll take your soil, we'll dry it, and we're able to store those soils for, it wouldn't be ideal, but up to a year, but we can certainly store them for about 6 months for this test, yeah. So for us operationally, it works really well because our hope is that we can collect these soils from you in the fall, run them when we have enough through the winter, and then give you the results in time for you to make some decisions in the spring. And it works out well for us operationally because we don't have time to do much more during the growing season. We're getting an influx of soils, and if you see our kind of sample numbers, they really increase during the growing season, and so we're kind of pumping. And our other challenge is typically when the weather's nice is also when people want to take a little bit of vacation, so we can't really deny people of that. So we're really pleased that this test is one that we can run during the winter. But it's a little bit different because we're used to trying to achieve turnaround times that are quite quick. So when you send your soils in, we hope to have a turnaround time of, I think, 7 to 10 business days. Yeah, so we like to get those results back to you right away. With this test, it's not going to be like that, so that's something that you have to keep in mind. If you submit in the fall, when we get a group of 20 soils, we'll run them, and then we'll give you the results back. So a little bit different. So what we do is on that air-dried soil, we do the first leaching, and technically that first leaching actually is the residual nitrogen that's left in your soil. So it's anything at the end of the growing season that plant hasn't taken up. So that in itself is actually kind of a useful number, and that's probably a conversation for another day. We can talk about potentially how you might use that. But what we were interested in is the second leaching. So then we take these soils, now they're wet, and so those organisms have woken up, and we put them in a nice cozy incubator for 2 weeks, and there's lots of oxygen. There's a film on top that will kind of keep them from drying out, but will let oxygen pass through. So those microorganisms during those 2 weeks are kind of partying, if you will, and they're enjoying whatever carbon is in the soil, and they're in turn mineralizing nitrogen. So after 2 weeks, we do the second leaching, and whatever comes off that second leaching is what we consider the BNA test results. So that second leaching, 2-week incubation, we measure nitrogen again, and are able to quantify that, and we say that's your BNA test result. And it looks a little bit like this. So this is results from Dalhousie University. These are results from Nova Scotia, and these are the results from 800 soil samples taken across the province, and this was all part of Dalhousie's soil health work. Through the, I'm going to get this wrong, but through the Sustainable Soil Management Center, I think, or I'm looking, but yeah, there's too many acronyms. But they do have, through Dalhousie, a research group that's dedicated to sustainable soils, and so it's out of that lab. And these values came from that as well. And so they have, there's one that's not quite showing up on the screen there, it's just cut off a little bit, but that's all right. Don't know what that last one is.
Wild blueberry, I think.
Oh yeah, wild blueberry. Yeah, that is important, isn't it? So sorry for any wild blueberry producers in the room. Sorry, Thomas. Okay. What they did is they looked at 800 different cropping systems, and they plotted here the results of the BNA test. And it's in milligrams of nitrogen per kilogram of soil. And so when you look at this, there's a couple of things that you can see. One is there's actually quite a bit of variability in BNA, even within cropping systems. You may look at some of these values and you can start to see in some of them there seems to be maybe a little bit of a trend in some of them where you can see most of the results sort of lie within a certain area. Dave did some statistics and just looked for differences of means there, which are denoted by those little letters. So anything that has a similar letter is not significantly different. But you can pull out a few conclusions from this, and one of the conclusions you can look at is that if you look at forage and pasture, they're not significantly different, and the B&A results seem to be a little bit higher in the system. So that's one of the conclusions that might be able to be drawn. But all in all, when you look at this, you can say, yeah, okay, there's a lot of variability, and that's interesting, and different cropping systems look like, yeah, there may be some differences, but really, what does that mean? So we did kind of something similar, and I spent a good part of last week trying to find a free download of statistical software, and I came up with a trial version of this one, and unfortunately it didn't allow me to run the statistics I wanted to. So what you're looking at is you're just simply looking at the data. There's no statistics applied to this, so I can't tell you what's statistically different. But these are the crop groups as you gave us. So this is what we received in terms of what you told us you were growing. And I put in a median line there of 25.9, and again, this is milligrams of nitrogen per kilogram of soil. And again, you can see there's some diversity among crop groups, and then maybe some trends that are happening within crop groups. So it's still a little bit murky, and at the end of the day, again, what does this mean to you? You sure can, yeah.
You separated out by soil type or by like organic amendments. Do you have that information?
Yes and no. Part 6 of this project maybe. Good question. Because I mean, yeah, when I look at this too, I mean, there was one strawberries. There was strawberry fields there, and I think it's you can see most of the values, for example, lie underneath the average, but then you've got a few that are lying above. And so I'm wondering, okay, are those new strawberry fields? What are the soil organic matter levels like in there, and what are the soil texture? So, what's that?
Or they matter grow, like
Yeah. Exactly. And I think that's the value of this at this point, is to ask more questions. With the data Cheryl has, there's probably potential to try and make some of those linkages. But again, you're going to have to run the statistics and do so. And so right now we're just looking at what we received and looking at the raw data, basically. Yeah. Yeah. And then so to get back to my title slide, biological nitrogen availability, it's all well and good. Caitlin mentioned these indices often, they say, if you get that value, whatever it means, they'll put it into context for you in terms of how many samples they received and whether that's good, okay, or not so okay. And the whole premise is that more is better. And arguably I'd say, yeah, I don't know, I don't really buy it, I don't think more is better, because I think in some cases your soil may be mineralizing more nitrogen, and that is a potential loss if it exceeds crop demand. And if it exceeds crop demand at the time, then that plant needs to take that up. So where do we go from here? And this was, I think, the exciting part of this project, is that trying to find something that was a little more practical and a little more meaningful. And so this is where things get really fun, because it involves a lot of kinetic equations. And this was also a deep dive for me over the last couple of weeks. Dave had kindly given me his spreadsheet in order to run these numbers. And of course I have to go through everything to make sure I understand it, and I think I do, but we'll see. So hang on, folks, because we're going to talk a little bit about kinetic equations, but this actually is important because this is kind of where all this information is derived from. So in order to translate B&A into a predicted growing season and mineralization, again, this was based on a lot of the work from Desiree Rompre in 2015. And at this time, and this is not a new concept in trying to apply an equation to some kind of a biological or chemical transformation. And so really what they did is they collected data and they tried to best fit a mathematical model to this data. And there's quite a bit of work outside of Nova Scotia, outside of the Maritimes, kind of across the world that does this, but a lot of this work really is quite regional in nature when you're trying to come up with these models. So there's a number of ways to approach it, but what they found is that in fact there were two of these models that kind of explained what they felt was happening in the ground. So they used two of these kinetic models to try and explain, I guess, or describe mathematically what's happening in this really complex system. So what she decided with her colleagues was that growing season and mineralization was really the results of two pools. One was this labile pool that probably is a little more reactive and turns over a little more quickly, and one was a more stable pool. And they had two different equations for each of those pools, added them up, and they said this is probably going to be what your growing season available nitrogen is going to be. And you can see there the kinetic equations are actually listed. So there's a first order equation and also a zero order equation that they used. And so when they applied these equations, they came up with a growing season and mineralization in 130 days. So they're saying our growing season is about 130 days. That's all based on that kind of time frame. And like the previous slide, plotted this out, applied some statistics to see whether there were any differences among these groups, which are denoted again by those letters, and the averages of each of those groups are they're listed on top of the dots. So this measurement is a little more relatable because it's in kilograms a hectare or kilograms of nitrogen per hectare. So that's a measurement that you guys can relate to, because when you're starting to put fertilizer on, you're thinking, how many kilograms am I going to put on per hectare? What's really, really crazy with this data set, if you look at those values in some of these soils, you know, that first one in forage crops is nearly 800 in a growing season. You know, it seems like an insane amount of nitrogen that your soil's producing. Now, that's a little bit of an anomaly in this data set. If you look at the rest, they're a little bit lower. In fact, if you look at the averages, they're lower again, and so it seems a little more palatable. But the point is largely we have been really underestimating how much nitrogen our soils are producing. So we have not been doing our due diligence in giving our soils credit for the ability to do this mineralization process. And I'd mentioned before, traditionally we were using kind of a very crude metric of, you know, based on organic matter, if it's 3.5, okay, we'll give you 15 kilograms per hectare. Again, this is where I think this gets interesting, because hopefully we can fine tune some of those recommendations. And in some of your soils, you likely have significantly more credit than just 15, so, or less in some cases too. So I know initially you're going to think, I don't buy it, because I know when I put the fertilizer spreader on and I put a double amount, everything looks amazingly green in that one spot. Just on the edge of that, it probably burnt the crop as well, you know. But I know, and I've seen that too in the field, and you're like, wow, more, and then you get this more is better mentality, and I think everybody's really reluctant to try and come back on their fertilizer amounts, especially with nitrogen. But the thing about nitrogen that I really want to stress is we're looking at applying optimal amounts. When you have that incident happen and you've applied double the rate or triple the rate or whatever, and you see it's green and it's thick and it's lush and it's growing like crazy, not fantastic. Likely you've put on so much that over the course of the growing season, that plant has had the right amount of nitrogen at the right time, at the right place, the right amount. It's at everything that's needed. Not by careful management, by over applying so much that there's going to be enough there to carry through the growing season. But what you can't see is how much you've lost. And this is the real conundrum with soil and nitrogen. You can't smell it, you can't hear it, you know, you can't see it. So when you're losing it, I wish soils would hiss when you're losing nitrogen, you know, because you'd be driving through, you know, Rawdon, and you'd have your window down, and you'd be like, oh my gosh, you know, geez, John's soils are hissing like crazy, he's put too much on, right? And that might make some change, but we can't. And so what we can do is try to measure it, try to sort it out this way. Yeah, this might be a little tricky for me to go through. Yeah, and I have a link to, I'm just trying to think the best way to do this. I have a link to a spreadsheet. And I I'm going to try and pull it up here actually, because this is where I hope, if I've lost anybody with those high results and that ability and your soil's ability to produce nitrogen, I hope I gain you back through this spreadsheet. Yeah, okay. And I think.
I think what I did was add a text that was
The presentation.
Yeah.
Which is here.
Yeah.
Okay, we're just going to take a minute here, and I might sit down for this because I think I'm going to have to. Okay. So I'm going to go through this just kind of high level, and let me know if I'm confusing things, and I'll try and kind of bring it back. So we talked about growing season, the amount of nitrogen available during the growing season, which we said was 130 days. And I showed you some wild results that some of our soils are like really good at producing nitrogen. So that's not the number we're using. So how we get to the number we're using is through this spreadsheet. So the number that you saw was this N mineralization number. Yeah. Okay. Some of us, our eyes aren't just good as they used to be, are they? I think that. So we have our BNA value, which we did in the lab, and I just showed you was that 2-week incubation, yada, 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 measure nitrogen at the end. In order to do this, the remainder of the calculation, we also have to measure nitrogen as well. And just a fun fact in the lab, these are run on 2 separate pieces of very expensive equipment. So all in all, when we start talking about this test, there's a number of different pieces of equipment that measure this. So again, it's not just one probe we stick in and we get the number. It's quite a process. So with the BNA value and total nitrogen, we use a number of different equations. I mentioned that Desiree Rompre had done these mathematical models that were the best fit for the data she had to try and predict what's going to be available in your soils. So there's 3 factors that are important. One is this constant factor, again, that's based on a mathematical model that really attempts to account for things like climate and other factors that are going to affect this process. The next is this stable pool, which we saw. She had 2 equations that she felt best described what was happening in the soil. So this is the stable pool that she had come up with, and actually if I click on this, the equation looks a little more simple. So that was a first kind of order kinetic kind of mathematical model, and that was plus this other equation, which was more the labile pool. So here we go, and that gave us our N-min results. So up until this point, this is where we've gotten. The last slide that I showed you with those really kind of impressive results, when there were about 800 kilograms per hectare nitrogen, that's that slide. So here we are, this is where we've gotten. What you're getting from us is not that. There's a few more steps that were involved in this. So what we do then, this is just a conversion factor. This estimated N mineralization over 130 days is really just a conversion factor. So you can have it in a unit that's more meaningful to you. So that's kilograms nitrogen per hectare. Then there are a series of risk factor, uncertainty factors that are applied to this value. And so the first one is this risk factor of 0.8. And I'll show you in a little bit. There's some work done by Luke Lawrence, who did a PhD and finished that work last year. And he was looking at a number of different ways to try and come up with this prediction of nitrogen in your soil. And one used the BNA test, and he looked at 2 other methods, which I'll just touch on later on just for fun, because maybe it'll give some light in terms of where this all might go in the future. Anyways, he looked at 2 other methods to do that. But the best method that he found in his work was the BNA test. It wasn't perfect, and that's why we're giving it a 0.8 factor here, multiplication, because there is some uncertainty with it. So that value that we've got, we've just reduced it by 0.8%, yeah? this one is going to make sense. The next factor is your active N crop uptake. So we know not all crops are going to grow within 130 days. In fact, the only ones really, arguably, that well, there are a few, I guess, but that in this system that do in terms of active N crop uptake would probably be forages, right? Pasture and forages. Other than that, if you're growing lettuce or if you're growing any other crop, that active N window is not 130 days. So you take what that window is, and Dave gave you some values in terms of the crop categories that they're using. And so let's say it's, I don't know, let's say it's 60 days. So then you take 60 divided by 130, and that gives you your next factor. So this factor, this risk 2 factor, active crop uptake, you'll see it changes. And these values that are changing according to the crop year that's being grown. So that makes sense, right? That does actually make sense.
That forage is a 1, I assume, because it's constantly growing.
Yeah, 100%. The comment was forage is a 1 because it's constantly growing. Absolutely right. I mean, I'd like to get forage bigger than 1 because I think it never stops growing, probably. But yeah, absolutely right. So then the last factor, and this one is the one that makes me a little bit sad, but I think is a bit of a case in point here. This is a 0.5, and this is actually an end-use efficiency. This value of 0.5 is actually derived from research that's shown when you apply fertilizer, really, it's about 50% effective or efficient. So you're losing 50% of it. That's a big loss, you know. So is this fair value? Maybe. I'd argue it's probably a little bit too restrictive, a little bit too conservative, because we're not talking about applied fertilizer, we're talking about these natural processes that are happening in the soil. So very likely, this factor is a 0.5, but the point is, at the end of the day, the value that you're getting is actually a little bit more on the conservative side because of that. So I, starting out of the gate, kind of appreciate that, because if you're using this to try and reduce your nitrogen fertilizer, I know there's a little bit of apprehension to do that because you've left the spreader on a little bit too longer and you've seen where things really green up just before it gets burned, you know, and in your mind that's a little bit of a scientific experiment on your own, and I can't kind of deny that, but what I would argue is that if that was your approach, your losses are going to be monumental, and I think again the goal here is not just kind of let's get the best volume we can regardless of what it's going to cost us, let's be as efficient as we possibly can with our nitrogen use, so we're getting the exact right amount at the right time, the right rate, in the right place, so that we get optimal yield for market conditions, right? That's ideal. So I think everybody has followed that. Have I lost anybody? Yeah, awesome. Okay. So then after that, what we get is really what we're after, and this is the adjusted nitrogen rate to your recommended nitrogen amount, you know, which is really based on just crop demand and crop need. Okay, so I'm going to try and switch over back to the presentation and see if I can manage to do this. Look at that. Okay, so let's see how far we've come. So one thing I'll point out here, the growing season mineralization over 130 days. Dave had an average of about 120 kilograms per hectare. Again, this is without all of those conservative factors that I applied. So overall, he had about 120. With your results, which you provided us, we had about 132. So we're not too far off. So that's, as I say, that's without all those factors in terms of when is the crop growing there, how good is this model, and also how efficient really, and how long is that nitrogen actually going to stick around. So where do we go from here? So this is the question I'm really interested in. So now you know where we are. Now you know kind of what we're thinking. Now you know where your soils went. Now you know why it took us a little while to get them back to you, and appreciate your patience on that. And you also have an idea of what this would look like if you were to submit a soil for this test. What I like about it is that it's the first, to my knowledge, of finding a practical, fairly reasonable test method. Like, we can do this. It's a little bit harder than some of our other testing procedures because there's a 2-week incubation and the equipment we're using is lovely, also sometimes finicky. So Jody's both a technician and a musician and trying to get this going. But we can do it, and what I like about it is at the end of the day, it gives you something kind of concrete. It gives you something that says, oh, okay, my soil is actually producing probably about 30 kilograms per hectare of nitrogen. You know, this other field is only 15. You know, and so there's differences amongst your fields. So that's what I like about it. And what I am struggling with, and I think what I need help with, is how do we make this clear to farmers what you're actually getting? Is this the bee's knees? No. Is it good? Yes. Will it improve? I hope so. Are you going to see a change in 5 years? I hope so. And what I hope I don't hear is, geez, that BNA test was no good, they're already changing it, you know? It's not that, it's just I do think that this is not too bad. You know, we're getting a little closer in finding a practical test that we can offer you that actually means something as a very specific change in management practices that you can base on. So how we're reporting it is, and we struggled with this too, and kind of, you know, threw this around and say, how do we report this? You've just had probably a half an hour, probably not over time, sorry about that. You've just had a half an hour explanation of what it is, and so you're probably feeling fairly comfortable with it. But if you just sent us in the soil and we sent you this, would you be comfortable with it? So what we've done is we've put on total nitrogen, which is kind of meaningless for you, to be honest, but we measured it, so we put it on. So we've got that on as percent, and we do need that in order to calculate the rest of it. We put on BNA. Again, we measured it. I think it's probably a little bit meaningless for you, and I can see some people squinting. Sorry about that. I can't zoom on that because things on the slide, but you've seen them before. Yeah. So what we did is I should say Lori, put in a couple of extra lines within our LIMS system, and so we have a system at the lab that generates all these reports, and so when you get behind it, you have to kind of make some adjustments. Lori was able to make the adjustments to add in a couple of lines, and so there's 2 extra lines on this, you'll see. One is the BNA, that's a new line, and the next line is the one that I think is probably valuable to you, which is your nitrogen credit. And we plopped it right above your nitrogen recommendation. So the point would be is you take that and you'd minus it from the recommendation, and you're a little bit closer to what you should be putting on. Make sense? But we're not finished yet. Because what you really want to do, of course, is take into account all those other credits too that you're getting. And I think Ryan might be touching on this a little bit from PEI, some of the work, maybe a little bit, yeah. So the island has been doing some of this nitrogen budget work, and these are the other 2 pieces that are also really important, of course, is to try and give yourself some credit for plow down or cover crop or anything, and also give yourself credit for the amount of kind of organic amendments, whether it's compost or fertilizer manure you're putting on. And very conveniently, we also do that testing too, so you can send us your manure sample at the same time. And when you have this done, I think then you're getting closer to where we need to get. So again, we were really happy to be a part of this project. Just to give you a glimpse into the future, when I said expect changes, I hope we do have some changes. Caitlin mentioned in her presentation that organic matter really drives this nitrogen cycle. It might be that we find that there's a certain fraction of organic matter that fits a model that better predicts nitrogen mineralization. I don't know. This is work that was done from Luke Lawrence again, and it's difficult to talk about someone else's work because I didn't actually do it. So I'll do my best. I always feel like it's better to hear it from the horse's mouth, and that's not happening here today. But what Luke had done is he looked at a number of other predictive functions in order to try and, again, figure out how much nitrogen were being produced in growing season. And the first one he looked at is just simply taking the digital soil map. Can we use the digital soil map to predict nitrogen mineralization? Yeah, we can. Is it as good as the BNA test? Not really. And if you look at those risk factors, for that first tier 1 option, which is based on the digital soil maps, it's a 0.6. So less confidence in that one than we did in the BNA test. So the next group, he said, okay, what if we looked at organic matter, pH, and CEC off the soil test report? What if we used those values to try and predict nitrogen mineralization? And again, can we do it? Yeah, we can. How good is it? Well, in this case, they gave a risk factor of 0.7. A little bit better than the other, a little more information feeding into it. The models were a little better, but still not as good as the last one, which is the B of A test, which is what he looked at. So that's why we went with this one. It's not necessarily ideal for us. As I say, this 2-week incubation operationally is a kind of a bit of pain, to be honest with you, but I think it's worthwhile in the end of the day. Will this change? As I said, I hope so. I hope they find some other factors that we can kind of plug into this with machine learning and some of the digital soil mapping that's happening. I hope that it becomes easier and more efficient, easier for us to manage, and a better model for you guys. And I think with the continued work, you'll hopefully see that. But where we stand today is we've got this test at the lab. We're able to do it. Thank you so much for giving us your samples and trusting us with them. Turns out we did do it. You've got your results. And so now we'd love your feedback. So if we do go forward with this and offer it to farmers, we need to know how we can work with Perennia to the extension aspect of this. How can we incorporate this into nutrient management plans? How do you feel about it? Are you confident that there's some legitimacy to this, I guess? Are you comfortable cutting back some of your rates based on this? So those are some of the questions. Are you okay with sending your samples to us in the fall and not hearing from us for another few months again? So those are some of the questions. So I'll leave it at that. I think that's my last slide, but I do want to acknowledge, I'm really glad Lori and Jody could be here with us today. I also want to say when we do this, largely some of this work was kind of done off the side of our desks, which meant the other work still needs to get done. I work with a great team of people. These are the folks that work on getting your reports back to you. And just as a little aside, because I think it's worthwhile to know, when I started with the lab, I was trying to get familiar with all the testing that was being done, and I was getting my own kind of Coles and Notes version of training. And one of the technicians there, everything's anonymous once it goes past sample receiving. That's part of our QA, so we don't know. I can't give preference to tin samples, even though I'd like to, or they're all treated the same. So when they come in the lab, they're anonymous. But in some cases, of course, we know when we're testing, sometimes it's good, sometimes it's bad. And during my training, one of the technicians was going through what they do, described it in great detail, and when the results were positive, she said, and then we do our happy dance, And I thought I really appreciated that because I think it speaks to the commitment of this group. You don't cross paths with them very often, but they are in Harlow Institute. And while we're here today, they're working, probably doing seaweed composts and some other samples that have come through. So they're continuing to keep things running. So really appreciate this group. Those are my contacts. Please feel free to take a picture of that slide. If you don't have a chance to chat with me today, if you go home and you have some questions, give me a call, send me an email. I'd love to hear from you. As I say, at this point, I think feedback from producers is really important because we are doing this for you, and I want to make sure it works well for you. And so if you have questions, comments, ideas, complaints, whatever, please give me a call. We're here all day. You can also approach Lori and Jody. They're very familiar with aspects of this. In fact, more familiar with certain details than I am, certainly. So they're also a good wealth of information. And I think that's it for me. So we'll open it up to any questions if there are any, and if not, I'll see you at lunch. And I know I'm keeping you between lunch, but yeah.
Is there a recommended frequency for the test at this point? Or I guess a better question would be is, would you expect that B&A result to change on a yearly basis?
Yeah. Good questions, yeah. I would likely, so yes, to answer your last question, I would say, yeah, I think I would expect it to change annually. I think if I were doing it, I would likely do it annually and see if I could find any trends. Yeah. You may find certain fields are fairly consistent because your management practices are fairly consistent, and you may find you have some anomalies on farm, some surprises, but that's probably how I would approach it. The second thing to note is with this, Chris did a nice job this morning of looking at GPS. If we took these samples, and we're not there yet, but you could on your own. If you took these samples to reference them, and then looked for changes within your field and kind of did more of a precision agriculture approach, that would be an even better step, right? So we could launch into a whole nother conversation about soil data and location and everything else, which I think is incredibly valuable, has so much potential for you as farmers, but we'll save that for another day. So yeah, so I guess to answer your question, Matt, I'd probably do it every year initially, and then look for those trends, and then we may find that there's maybe every 2 years, every 3 years, I don't know.
But with annual crops, that factor that adjusts for the crop with rotation, you'd need to do it every year if you were in that situation.
I would think so, and I think with annual crops too, especially if you're changing, you're switching up your amendments, or if you're changing your crop rotation, which is a big one as well. So, yeah, with something like wild blueberries, I don't know. You're not, Andrew, you've had your head up for a while,
Is this research saying that the type of microbial activity in the soil is affecting the level of nitrogen in the soil?
So can you ask that again, just so I can?
Is this research indicating that the level of microbial activity in the soil is affecting in a big way the level of nitrogen in the soil?
Yeah, absolutely. Yeah, so.
Well, the Koreans have done a ton of research on this, and they're applying it very successfully through their methodology. They use the fermentation technique.
Mhm.
So maybe I'm just suggesting that the issue would be perhaps it's the level of nitrogen, but maybe there are ways to improve the microbial condition in the soil and applying a different type of fertilizer, a different type of treatment to the soil that would yield different results.
Yeah, sure, and I appreciate those comments. I also appreciate you bringing it back to the microorganisms in the soil. One of the challenges in soil science is we can measure microorganisms, but in agriculture, what we tend to be interested in is the results of the microorganisms, which we're measuring now. And to your point, you're sort of suggesting that there's all kinds of changes that will affect the microorganisms and the community structure of the soil, I think. And yeah, you're absolutely right. Yeah. So I think it's probably a little more of a comment than a question, but I appreciate it. Yeah. Thank you, Brian.
When you guys have the nitrogen credit on your sheet, which I think is great, hopefully EI Lab will do as well. Is that just the DNA credit, or is that
That's the So we do list the DNA credit there, and again, this is open for discussion. We can change this. What I think really is probably at the end of the day as a farmer, what you want is your credit, But I don't want to get. I guess I like to still imply that there's some complexity to this, and so I think by adding the DNA value there, it kind of reminds us that this isn't just here we're going to give you a little extra credit here, And as I say, when these things change, also as a reminder that there's good reasons for it too, I guess. So yeah, thanks, Ryan. Yeah. Yeah. So as a registered farmer, you receive 50% off all of our testing. Our costs are based on cost recoverable, so we don't profit off of our testing. So we do an analysis to recover the cost of our consumables, basically, to run the test, and of course the time of the technicians. On this right now, we've had it set at $30 with a 50% discount to a registered farm. That's $15. However, that's just for the BNA test. Because we have to use a totally different piece of equipment to measure total nitrogen, there'd be another fee for that. And what would that be, Lori? Okay, so that test for total nitrogen is done in our LECO, and I'm going to guess be similar to what it would be on the manure test report. So I want to say like $7 at the discounted rate. Laura's going to check. Yeah. So it would be your total nitrogen cost plus the BNA cost. So at 50% discount for a registered farm. I don't think it's cost prohibitive is my answer to you. Yeah. And those fees may change a little bit. This was a pilot project, and so we're still kind of working this out as we get more efficient. We'll see where everything kind of shakes out, but that's where it is kind of right now. If that gives you a rough idea. Yeah. And I don't, as I say, I don't feel that's cost prohibitive. I'm not doing 100 fields, of course. And you may not want to use this on 100 fields. Maybe you want to just pick a few and kind of get a lay of the land at first. But, yeah.
Was there any analysis done on when the sample was taken?
actually taking it for this set. I think loosely the advice would be after the crop has stopped growing, kind of, so we're assuming, making some assumptions there that things have kind of slowed down. As I say, everything kind of ends up with a baseline with this test because we take the soils, we treat them all the same, we dry them, we do that initial leaching, and then the BNA test is based on that. So it takes out a little bit of that variability, I think, in terms of the end of year when it was sampled. But good point in that you probably want to take these samples after your crop is off, after you've harvested, if possible. Yeah.
I looked at EEI, it wasn't, you took it late enough, like, you say, like October, November, and compared it against like pre-planting soil testing, like April or something, there was really not a lot of it.
Oh, perfect. Yeah, thanks for those comments. That's great. Thanks, Ryan. Yeah.
Have there been end response trials looking at giving that credit and how that affects yield or quality?
Not yet, but I have some friends at Perennia that I think would probably love to do some of that work. Yeah. No, I shouldn't say not yet, Rosie. I don't know. From our standpoint, we just kind of are able to offer this. I think that would be the next step. And I think, if I were to do this on my farm, I'd probably like to, split the field into strips or something if possible. You can do some of your own trials on your farm and kind of look at reducing some of this. And I say that carefully too because you're going to do it in a year where it's going to be really crazy rain or something, and then you're going to say it doesn't work. I do it over a series of years to kind of make up for those weird years. I feel very confident that we can do a better job of managing our nitrogen. I feel very confident that we are losing way more than we realize, So I hope this is a tool, but if I were to use it, I don't take anything as kind of the gospel. I take it as another piece of information. I think you also have to be really careful, and your fields better than anybody. So I think you have to take all that information that you've gathered over the years of farming, see, hey, this is another piece of the puzzle. This is a little bit extra information. How are you going to apply that? Yeah. But end response trials would be amazing. Yeah, as the next step. Yeah.
And then the adjustment factor for crop, take lettuce for example, you plant lettuce in your first planting where your soils are really cool, you have much slower mineralization than like midsummer or late summer planting. So might be 60 days across the board, but
Yeah.
is that gonna change or is that gonna be another factor added?
Yeah, good question again, and this is actually a question I had to go back to Dave with. So we will have a debriefing session on this, and so the question was on that active and uptake period. There's so many variations in crops we grow here. The categories were a little bit limiting, I found, even when we did this. So I'm kind of grouping things that I know that active end window is probably a little bit different. So how exact can we get on that active end window, I think is your question, hey? And I got to go back to the drawing board and ask that too, because I'm not even 100% sure, to be honest with you. It's not from when you put the seed in the ground to harvest, because it's going to spend some time trying to germinate there too. So at what point are we considering active and uptake? Yep. Good question. Thank you.
Yeah, with that current calculation with the 130 days, is that just extrapolating that 2 weeks in like optimal conditions, essentially?
Yeah. So that's so then there's a series of kinetic equations that are used
The
based
reductions
on,
afterwards.
yeah,
of course.
based on longer incubations and based on some field research too. So it's sort of been, as I say, this is based on probably about 20 years worth of work. So I don't want to give the impression we just kind of pop some things in the incubator and put some calculations to it and release some. But yeah. Any other questions? Yeah.
So it's really nice to see the biological soil being taken into account for nitrogen calculation to be able to bring in. You said this is just in its early stages. What other part of the plant soil microbe interaction are we not capturing yet?
Okay, lunch is canceled. I gotta call some friends too. That's a great question. Yeah, and that's why I say I think this is going to change, because I think, and some of those factors will have a different amount of influence on these transformation than others, right? So I think that's where I keep saying my disclaimer is I hope this changes. I hope in a couple years' time or a few years' time we're back meeting again and we're talking another nitrogen test that works a little bit better and a little more accurate, a little more practical. But I don't have a great answer for you on the spot. And as I say, that's a whole other week session. But I really appreciate the comment. Yeah, thank you. Yeah.
Actually, that, back to that, especially gives experience to a lot of these center samples from that here, so we have usable data for American probably how that was a scale. Well, it's set it off, going down. I expect to have packages less for us here, because you need to build a database of
Yeah.
lots of over.
Yeah, and I hope everybody had a chance to hear Tim's comment. I feel like I should give you the mic and probably $20. So Tim's comment, I can repeat, okay, and you guys can fact check me to make sure I'm repeating this correctly. Yeah. I think, Tim, your comment was the importance of having a provincial lab, which I agree, and kind of the value of being able to collect regional data. You know, part two of this, and I know Chris and I have had these conversations at length, like we're sitting on some really great provincial data. Another workshop at another time, I'd love to have a conversation with farmers in terms of, are you comfortable with us using that data and how? Right now, you own it, and so our capability of doing much more with it is really limited because of privacy of information, which I respect and I think is really important. But if you're aware of how we're using it and what we might be able to do to be able to carry the industry forward, you know, I think there's a lot of potential there. And while I have the floor, just because I think that's a great comment, and because I hope that this is going to cause everybody to think a little bit when they go home and kind of wonder where we're going to go with this. As a farmer, with us, would you be comfortable identifying the spot in your field where you took the sample? And how would you send that location into the lab? Or who collects that? You know, how do we do that? We've had these conversations in the lab a little bit too, and my comment is, oh my gosh, like some of these GPS points are a number of digits long, and sometimes we have trouble getting people to allegedly fill out an email address, let alone a GPS location, so I'm quite sure we end up with some locations in China. so that's one challenge. So a whole lot of things to work out there, but really appreciate that comment. So yeah, I mean, I think I'm biased. I'll come, you know, of course I'm biased, but I do think there's a lot of value in the provincial lab, and our goal is to continue to make sure that there's a lot of value to you as producers to have your provincial lab, which includes this test. So yeah, I appreciate the comments. Yeah.
Something to work forward to is consent for farmers to allow that information to be used
Exactly.
as a mapping project almost for trends in areas.
I love it, yeah, and again, we've had the same conversation, so if you can't hear the comments, I apologize, but it's kind of like, how do we get consent from farmers to use their data for certain projects? And we have our processes in the lab, and I think it's kind of an understanding of how we collect information and how we have our processes, what makes it easy for farmers to submit that, and if we can marry the two, and who can we share that with, you know, and so how do we kind of, as a community, work together to kind of pull this thing forward? Yeah, thank you, yeah.
Great. Any other questions? I think we're going to call it, and we're going to have some lunch, but thanks. Perfect.
I'm going to give a quick introduction of our keynote speaker here, so I'm just going to read verbatim. Ryan Barrett, I'm sure many of you know him. Ryan Barrett is a research and agronomy specialist with the Prince Edward Island Potato Board in Charlottetown, PEI. In this role, he coordinates local and national research projects with a number of different partners, as well as conducting on-farm research trials with PEI potato growers. Ryan serves as the lead on 3 projects under the ACS Living Labs program on the island. Ryan is a professional agrologist and serves as the president of PEI Institute of Agrologists. He is also a certified crop advisor for the Atlantic provinces. He also serves as chair of the Canadian Potato Council Research Working Group, as well as serving on a number of other agricultural boards and committees. Ryan graduated with a BSc in agriculture from Dalhousie in 2002 and an MSc from the University of Guelph in 2004. He has worked with the PEI Potato Board since 2012, after previously working in the purebred dairy cattle industry. As well, he continues to be involved in his family's dairy farm, breeding registered milking shorthorns. Ryan also serves as Secretary Manager of the Canadian Milking Shorthorn Society. So, give it up for our keynote today.
Obviously need to give Georgia the short version of that. You have one bio folder, and you have one bio because everybody's asking for bios when you're speaking and things, and then you just, oh, here you go. And then you realize, oh, It needs to be a lot shorter when they're actually reading it out. So thank you very much for the invite to come and talk today. It's always a pleasure to come over to Nova Scotia. Took a little different road than I normally take today, and that was twisty turny but lovely. And always a pleasure. I don't get to come over to Nova Scotia to talk that often because you guys don't have as many potatoes. But I'm hopeful that quite a bit that I can talk about today will be applicable regardless of your cropping system, particularly if you are in a horticulture but non-potato system. I think there's quite a bit that should be that should relate. So we'll kind of dig right in. So soil health is a priority. I think we all recognize that soil health is a priority, and I know when I talk to my growers and when I survey them or ask them for their feedback as to what are some of their research priorities, what are some of the things that they think we should be doing trials on or research on, soil health is always basically at the top of that list. It's usually always one or two. And so why, and what do they want me to look at? They want to be thinking about optimizing rotations that not only optimize for the crop, but optimize for the health of the soil. They want to reduce soil-borne pests and diseases, which I would argue is a part of soil health that sometimes gets ignored or overlooked, but particularly in horticultural crops and crops that grow under the surface of the soil, those pests and diseases are a big thing. We of course want to improve water holding capacity and PEI. We're only about 10% of our crop is irrigated, so doing more to naturally manage the water availability to our crop is important. And I would say dovetailing with that is just buffering the effects of climate change. We're seeing periods where we get a lot of water in one day or in a couple of days. We get 3 or 4 inches in a day with a tropical storm that comes in September. But then we could have 4 or 6 weeks of barely any rain like we had in parts of PEI this summer. So the more we can do to improve the abilities of our soils to buffer those changes, the better I think it will be. But there's also a big difference between the priorities of the growers and when it comes to soil health, and what's the priorities of the industry or the priorities of consumers, or the people that are buying our potatoes. And they're looking at things like carbon sequestration. They're looking at things like fertilizer and pesticide usage. They're looking at things like biodiversity. Those things are important to growers too, but they often don't pay the bills the same as the top ones. So I think it's important to understand where both sides are coming from, find out where we have ways to have those kind of intersect and work together, and also find out ways that we can focus on some of the win-wins so that growers are coming ahead but responding to some of these other things that I have below. So as I say, in my research program, or the people that I've been working with at PEI, we've really been trying to focus on some of these win-win outcomes. So what are some of the best management practices that are associated with improved soil health, but are either reasonably easy and reasonably inexpensive to implement, or the implementation cost of them is well exceeded by the benefits. So we've been working on this quite a bit, and for the growers that I work for, whenever I talk to them about what's the biggest thing limiting adoption of a new BMP, it's usually not money, it's usually time. And so it's usually, I do not have time to do one more thing. So I need you to find me a way to make this actually take less time, or a way that I can find operational efficiencies to make this important. So I kind of bear that in mind as I'm looking at these projects as well. I'm not going to go into every project, of course, that we've been doing at BEI. This is just a bit of an overall list of some of the projects that the Potato Board and I particularly have been working on. So we've done quite a bit on cover crops in the last 5 to 6 years, both sort of immediately before and immediately after potatoes. We've been looking at sort of full season cover crops or service crops, mostly focused on either building soil organic matter or fighting soil-borne disease and pests. And that's where some of these like biofumigant, mustard, and disease suppressive crops come in. We've been doing a bit of work with that. Finding new ways to both measure and mitigate soil compaction. So we've been doing a bunch of work on that because I think that's a silent yield robber that we often don't pay as much attention to as we should, especially in a tillage-intensive crop like potatoes. So something that we're paying a lot more attention to. Looking at the effect of legumes on potato yield, we've been growing legumes in potato rotations with PEI for 100 years or more. And often I don't think we give enough credit on those nitrogen credits, but those nitrogen credits are highly dependent on species, termination timing, tillage, lots of other things. So we're looking at those things as well. And just recently in our last Living Labs project, I've started some work with some beef producers and potato producers looking at grazing and potato rotations and looking at effects on soil health as well as potato yield. And then there's some of the other partners we work with. We don't operate in a vacuum. We have lots of terrific partners that we work with. So Dr. Niraneza at AFC in Charlottetown has done extensive work on traditional moldboard plowing versus more like vertical tillage, residue tillage. I've partnered with her a little bit on some work there. We talked this morning about BNA, so I've done a lot of work with Dr. Burton and the PEI Department of Ag and a bunch of different partners on that type of research. Done, again, work on sort of alternative full season and fall cover crops, starting things at the plot scale and then taking them out to the field scale. And then also work on soil amendments, not just your regular amendments that we're used to, like manure and maybe, you know, beef compost, but things like biochar, things like wood chips, willow chips, different things. So there's a few different things. And this is not an exhaustive list. There's other things going on by other partners. These are some of the ones I might focus on today. When it comes to the fall seeded cover crops, so something going on after harvest or after another crop termination, I always say the number one reason to have a cover crop is soil erosion. Everything else is gravy. The number one reason to do cover crop is to keep soil in the field. And the number 2 and 3 reasons are also to prevent soil erosion. So it is the number one reason. And if you have erodible soils, if you have elevation, if you have, you're in an exposed windy area, any of those things, trying to provide some barrier to soil erosion I think is important. And again, we're in a situation in PEI where, you know, there's a certain amount of tillage has to come with potato production. So we have to balance that by when we don't have bare soil, try to keep it as covered as much as we can. And this is going to be highly dictated by where you farm. So if you farm in the valley over here, you guys usually lose your snow and it warms up a little faster. You might have a little longer in the fall than we do. You might have a little different establishment window than we do at PEI. But then even at PEI, we have a longer establishment window for fall covers than, say, the potato belt in New Brunswick. So it very much differs based on where you are, and so you have to look at that local research, look at that local experience of your peers and your neighbors to figure out what works. But really, what's our overall goal? Have something green and growing the maximum number of weeks possible. The maximum number of weeks that you can have something growing, you're preventing soil erosion, but you're also building soil organic matter. And I acknowledge that after certain crops, especially grain, corn, soybeans, potatoes, turnips, things like that, sometimes we're harvesting those in November, and it can be pretty problematic to get covers on. So we just have to try our best, and we have to look at innovative ways to do things. I looked at, in PEI, a lot of the standard rotation for a lot of years is usually potatoes, and then grain, and then after grain is usually some sort of forage crop, or sort of disease suppressive crop or something like that. And a lot of those fields would get plowed late fall, historically, and a lot of people have been moving that tillage up to earlier in the year and looking at things like getting covers on at the same time as the due tillage or immediately after, you know, terminating an alfalfa crop in August instead of in October and getting a cover on and getting it up and established really well. And what we were finding is that having more acres covered in the fall ahead of potatoes we found significant reductions in soil nitrate levels, which is in our sandy soils in PEI is just nitrate that's going to leave the system. So if you have leftover nitrate in the fall in PEI, you aren't going to have it in the spring. So it's about trying to keep it and sequester some of it to come over the next year. We saw significant reductions in soil displacement, i.e. erosion. We did see a 10% yield increase in potatoes ahead of potato. You know, will you see that in every crop? Probably not. In a high value crop like potatoes, and especially a high nutrient requiring crop like potatoes, I think you probably see more of a yield increase than you would in corn and beans, but that's what we saw. And what we saw is from basically when I started polling growers about cover crops ahead of potatoes. When I put my first survey out in 2019, before we started Living Labs, about 25% of the acres before potatoes had cover crops, and last year it was closer to 60. So we are seeing like the results of the research that are showing that there are advantages has helped to increase adoption, as well as people talking to their neighbors and finding out, oh, it's really not that hard, and we can put a cedar box on the lemkin and just do it all in one pass, and you know, it's really not that easy, not that hard. So we did see in the last year of this Living Labs project in particular, we saw a small increase in organic matter across all of our sites when we looked at cover versus non. That's not something I'm comfortable hanging my hat on, but it's an indication I think maybe we're in the right direction. We talked about active carbon this morning, Caitlin did. We did see a trend towards higher active carbon. Again, probably not statistically significant, but definitely a trend in the right direction. And this kind of, because it's really hard to measure those soil differences in 1 year, because a lot of these trials were just like cover crop, production crop, cover crop, production crop. We're trying to look at that more of a long period. So I have a bunch of fields as part of a new Living Labs project where we're actually tracking the same parts of that field for 5 years and seeing where we have a cover every fall versus where we don't have a cover, what's the difference that we see. Just a little bit of a graphical explanation of what we saw in a few fields. The green is where we had a fall cover after termination of a alfalfa crop in the summer. The red is where we didn't have a cover crop. And we see anywhere from a 2 to 4-fold reduction in soil nitrates where we had that cover. Those covers, if they're planted early enough, can scavenge quite a bit of nitrogen and carry that over to the next year. And this is just what we saw in the yield improvement. So my units are in hundredweight per acre and dollars per acre. And as you can see, we had about a 32 hundredweight per acre increase, which is somewhere around 10%. It was very highly statistically significant. I think out of those, was there 19 site years? I think not 17 of them were positive. So our win rate was pretty high. And if you were doing that on a cost, cost of implementation, these dollar figures are a few years old. The cost of potatoes has probably gone up 40 or 50% in this amount of time. But we're looking at about an 8 or 10 to 1 return on investment in terms of doing those cover crops. So we also looked at covers after potatoes. That's a little trickier. Lots of people want to get something on after potatoes, but if you're not digging potatoes until after Thanksgiving sometimes, what are your options? And so in PEI, we definitely found that the winter cereals are more reliable. They stay green longer. They'll generally survive the winter. They'll green up in April, maybe even March, depending on the year. And so we have seen an increasing amount of winter wheat grown in PEI, also an increasing amount of winter rye. What I will say is we did a few trials, we're looking at the seeding rate. Some people are saying, oh, well, I'm going late, I better up the seeding rate. We didn't actually see much increase in percent cover by upping that seeding rate by even double the amount. So it's more important, the timing is more important than the rate. So I really focus on that. Those early seed covers really do scavenge more nitrogen and protect the soil. We did a little work with winter barley. Is anybody using winter barley over here? Yeah, a couple of hands. We, in PEI, we basically saw that after potatoes, it made a tremendous cover, and we could not get it to live the next year because I think we were putting it in too late. So if any of you guys know Wheat Pete from Ontario, Wheat Pete Johnson, he basically says, what's your optimum date for winter wheat? And then back it up 2 weeks for winter barley. And for us, that's before potato harvest. So we may see it being used a little bit for cover, but if people are going to do it for a crop, it's going to have to go in after something other than potatoes, I think.
Your higher seeding rates, was that drilled or broadcast?
Broadcast. Well, actually, one of them was drilled as well, but most of them were broadcast. Not really. Yeah, definitely not statistical, like within 1% of each other, that sort of thing. That's just a little graph looking at, we looked at, this is days after establishment or days after planting for a few different cover crops that we did after harvesting potatoes. you can see that for the most part, the winter species did better than the spring species. You'll see the oats is actually a little better than the fall rye, but all of those oats were planted in like September, early October, and almost all the rye was planted after the 15th of October. So it's probably not, they're not by days on the calendar, they're by days after planting. So we are seeing, the winter barley did terrific. Like it really did a great job establishing. And I had all these growers, they had it side by side against winter wheat. They said, holy smokes, this looks amazing. Look at the tillers on this. I'm gonna go in and plant winter barley. And then the next spring, there was no more orders for winter barley seed. So lots of conversation about full season cover crops. So, you know, out here in the Maritimes, sometimes on a commodity basis on some crops, it's hard to turn a dollar. And, you know, we can grow anything, but it's just about getting it to market. We got a lot of growers at home that are tired of making $50 an acre or no dollars an acre on barley or feed wheat, and saying maybe I want to try and grow something that's actually building my soil. So we've got a lot of growers doing trials with me, looking at different mixes or different individual cover crops or cover crop dynamics, trying to look at what those impacts are on the potato crop. And we're not just interested in, of course, potato yield and quality, but also a lot of these soil health metrics. And in potatoes, we're also worried a lot about, you know, soil-borne diseases. So verticillium wilt is a big issue in potatoes in certain varieties. So we're looking at things like verticillium and root lesion nematodes, but then a lot of these other metrics that we were talking about already today. In our living labs research, this is just some of the different crops that we've been looking at, or individual crops or mixes. I would say most have their place. What I would generally say is that growers have probably had more success with individual crops or the 2 or 3 species mixes than a ultra diverse mix. Because sometimes the ultra diverse mix has a bunch of stuff in it that isn't going to grow in PEI anyway. It may be at such low rates that you don't see much of it. And sometimes, depending on if they're not timed right together, some of them can become then a volunteer or a weed problem. So it's important. I'm not going to badmouth all mixes because not all mixes are created equal, but understand what's in your mixes and make sure it's adapted for where you are farming. From all this, we had, I don't know, 20-some trials over 3 years as part of Living Labs, plus a bunch of other trials before and after. I wouldn't say that there was anything that was a slam dunk that's like definitely this ahead of potatoes, or, you know, like they all, I think it's field dependent, it's variety dependent, it's crop history dependent, but we did see a bit of a trend towards higher biological nitrogen availability following radishes. And I think that's in part because radishes grow fast and then break down fast. And so that releases a lot more back into the system ahead of things like spuds. We definitely saw a trend towards higher soil respirations following those like multi-species mixtures, especially those 2 or 3 species mixtures, just because I think we maximize biomass a bit more. And in most of these, like when we're doing a check, our check is what growers would normally do, and in that case, the check was often ryegrass or red clover. When we were comparing against red clover, we didn't see a whole lot of difference on the soil health side or on the yield side. We were comparing against ryegrass. We did see some improvement in yield with some of these, like, again, annual soil builder crops like your sedan grasses and radishes and mixes of those sort of things. But ryegrass in the head of potatoes sometimes can be a bit tricky in terms of even tying up nitrogen. If it gets really mature, that sort of thing. So this is just, again, just for, it's a lot of numbers, but basically I want to just focus on, we did see sort of some statistical trend towards a little bit higher yield and crop value on some of those soil builder crops as opposed to those ryegrass crops. And you know, we didn't really see much difference in quality, it was mostly just on total yield. Disease suppressive crops, biofumigant mustard. Lots of people talking about mustard all the time. In PEI, we do not have the ability to do soil fumigation with like chloropicrin or metamsodium or anything like that. So we've been looking at other options, and one of those options is using mustard, you know, as a plow down crop ahead of potatoes. We did see fields where it definitely worked. In some cases, it gave us a 50 to 70 hundredweight yield improvement. but it's very finicky and it's very tricky, and you really only want to use it on your worst fields in the tightest rotation with the longest history of potatoes and variety that's susceptible to the critters that you're worried about, like verticillium and nematodes. On lots of fields, we would see very little difference, especially if we're using resistant varieties. And so this is not, you know, I don't have the most recent cost of production. I'm doing biofumigant mustard. I'm going to say it's at least $350 to $400 an acre if you're taking seed plus tillage plus everything into the mix. You also have to fertilize biofumigant mustard a fair bit. You need about 100 pounds to the acre of nitrogen, about 25 pounds an acre of sulfur to be successful with it. But on certain fields, definitely had value. So we're not saying do not use it, but understand where it has value and where it has limits. The big thing with mustard is having water. So if you have irrigation or you have the ability to get, you know, a field that carries a fair bit of moisture, you will be much more successful with this type of an approach than a dry, sandy field that you can't deliver water to. And timing it, say, before rain or something like that is pretty important. Now, different from that is wireworm control. I don't know if you guys are seeing much in the way of wireworm down here or in your rotations. We have been battling wireworm PEI for a while. We have seen repeatable, consistent results in reducing wireworm damage with the use of brown mustard or buckwheat. And so some growers, especially fresh growers, like growers growing mini potatoes, that sort of thing, they are now doing like buckwheat first, plowing it in, mustard after, trying to tamp down the wireworm. And it does seem to do a pretty good job. We do have wireworm chemistry available as well now too, Symegra, but this does help. For particularly the poor fields, it helps.
Are you using a specific variety of mustard, or are you trying to clone seed works as well?
Most growers will be using Centennial brown mustard, which tends to be the most common brown mustard around home, and it as well as what termination date, and trying to figure out when that releases into the soil, and use that to kind of figure out what our nitrogen credits should be. And kudos to the growers that are doing this with me, that are leaving me parts of fields with 0 nitrogen on them, so I can do some bioassays on plants and try and figure out how much nitrogen. We had some potato crops last year in certain fields where we had 0 applied nitrogen that still gave us 300 hundredweight of gross yield of potatoes, and the yield on the full nitrogen rate was 350. So, you know, on a field by field basis, you know, there is, as Amy and others mentioned, some of these fields mineralize a lot of nitrogen, especially if you're following after a legume crop. So we have to do that math and figure it out. But if we're going to ask farmers to do that math, we're going to ask you guys to do that math and modify your nitrogen rates, you guys have to have trust that our numbers are accurate, or at least somewhat accurate. So that's why we're doing this work. Just a little bit on BNA for a minute. So we had our PEI Department of Ag worked with Dave Burton and some other local agronomy people in PEI over a couple of years, trying to compare recommendations of different nitrogen rates and trying to figure out, you know, if we backed off according to the recommendation from BNA, what will we see in yields? So I did not make this graph. I'm going to throw Kyra Stiles under the bus. But the blue, the blue on the left is at 100 pounds an acre of nitrogen. The gray is with what the grower standard practice on that variety would be minus 25%. The light blue is the grower standard practice nitrogen program, and the BNA is backing off or adding based on the credit that was recommended from biological nitrogen availability. And basically, if you look at that across the board, there's almost nowhere where the BNA was wildly different from the other programs. In some cases slightly above, in some cases within the margin of error. So it seemed to indicate that there was some value and some merit in decreasing nitrogen according to these BNA values. So that's being worked on additionally. And the spreadsheet that Amy shared, I'm hoping to get that used a little bit more routinely in PEI, but we need to get that kind of integrated into the soil lab and that sort of thing.
None of those are significantly different than 100 pounds of that.
Yes, because of lots of people over apply in. Yeah. I didn't do this trial. Most of these fields had legumes ahead of them, and those legumes did not generally get credited as much as they probably should have. The one thing I'll say about B&A in my experience with them, it does a really good job at measuring the nitrogen that's coming from applied manure, a history of manure, from your soil organic matter, from the overall health of your soil. It doesn't seem to capture the nitrogen coming from legumes as much, especially a legume that's going to take a while to mineralize, like alfalfa. So generally, when we've done this testing in the fall, we get a number, and that number is usually doesn't really capture what we think is going to be mineralized from the alfalfa, so we have to kind of add that on top as well. But for understanding what's coming from the organic matter and from, say, a manure or that sort of thing, it seems to do a really good job of capturing that. Also looking at things like tillage, so again, can't do no-till potatoes, not yet. So how do we minimize tillage? How do we minimize soil disturbance? How do we not go as deep? How do we mix the soil rather than just burying our crop residues? And you know, a machine like this, I know there's lots of these machines over here too, but like these Lemkins or Pottingers, things like that, where you can put a cedar box right on them and do everything in one pass. Remember how I said everybody doesn't have any time? Well, this makes a lot of sense. So we're seeing a lot of this in PEI, especially our large acreage growers. That's getting very, very common. Doing this, you know, killing clover or alfalfa, or going in after, you know, grain residue in late August, early September, putting the cover crop on, then at the same time one pass, and then a nice long fall for that cover crop to establish. Also, a few people that are experimenting with what we call hilling or ridging in the fall. And the main reason for that is, again, you're getting a cover crop on at the same time, but you're also increasing the surface area of the soil so that it warms up quicker in the spring. PEI, we're surrounded by, I drove over the bridge this morning and there was a fair bit of ice underneath the bridge, and that water stays cold for quite a while. It's not swimming weather till Canada Day. So that traps a lot, or keeps a lot of heat away from the island in terms of warming up in the spring. So anything we can do to increase kind of that surface area to get the ground warmed up a little faster, maybe gives us a few more days to plant, quicker to plant. And every day before the end of June that you can get a crop in is probably worth 2 in September in terms of light interception and degree days, that sort of thing. So we're looking at that. The other thing is, running one of these machines, I know it takes a bigger tractor than a plow, but when we did the economics per acre, it's less money. It's less money in operator dollars, it's less money in diesel, so it makes a lot of sense that way. Along with this, so Dr. Niraneza at AFC in Charlottetown just published a paper in the American Journal of Potato Research last summer, and she basically saw that where they compared this, vertical tillage alongside the mower plow, they saw these types of increases in some of these soil health metrics. And basically across the board, they saw some increase, and it was most acute in the soil respiration and the B&A. So, I think with no reduction in potato yield. And the years that she happened to do it were on wet years, where the potato yield probably wasn't as stressed. If it had been last year or 2020, we might have saw a little more difference, but that's where we are today. I mentioned grazing, so again, we have a lot of fields that are forages, and a lot of these fields are just mulch, so we're working with growers and some beef producers, looking at how do we reintegrate some of these livestock into some of these farms. Thankfully, OFCAF has money for grazing, for infrastructure, people that are wanting to do rotational grazing, so that's helping to support some of this as well. This year was our first potato year in 3 of these fields, so I've been tracking a couple of them for a couple years ahead in the grazing. We didn't see any big significant differences in potato yield, but again, we did see some preliminary trends on soil health in a couple of these fields, so we're going to be tracking a couple of these fields for another 3-year rotation, 2 years of grazing and then going into potatoes, so we'll see whether we see anything more to report on down the road. What's that? It's different depending on the field. So most of them, it's what they would normally have underseeded under their, you know, barley or their wheat or something. So mostly it's like a grass legume mix, probably a little heavier on the grass. In one field, we actually set up, you know, the grower had his normal rotation as the check. Year one of grazing was corn, which he grazed as like mature corn. Didn't graze until November. And then the next year was like a 1 year annual mix. And then the other strip in the field was sorghum Sudan grass that he grazed, and then underseeded with alfalfa Timothy, and then the alfalfa Timothy was grazed the next year. And so that corn, those cows ate every bit of that corn. And then that fall, like when I went out to soil sample, you could barely tell there was corn there. So they really did mow it down pretty well. But you know, we saw some differences. Again, that specific trial is the only trial where I saw a yield difference, and the yield difference was actually lower where we had, like, there was less potatoes where we had the sorghum Sudan grass and the alfalfa. But the reason is because there was no difference in the fertility rate. It's the same fertility rate on everything, and the alfalfa contributed a lot more nitrogen, and it stayed green longer. And I have some pictures where that alfalfa treatment was, in the potato year, was like rank green, and everything else was starting to die back, and the potatoes just stayed immature too long, and then by the time they killed the potatoes, they hadn't bottomed down enough, and so there was 50 hundredweight between them. If we had have adjusted the nitrogen rate, we probably wouldn't have seen that difference. Again, the things you learn doing field trials with growers. So, you know, that's why we're doing these living lab trials, doing these things, trying to figure things out on the fly. So in summary, I've covered a bunch of ground here. What are my take-home messages? My take-home messages is that improving soil health is a long-term commitment. It isn't something often we can measure in 1 year or even one rotation. It's usually multiple rotations. It's usually trying lots of things. It's usually having a bunch of those things not work right, and then adjusting and trying them again, and then they maybe work the second or third time. So it is part of a commitment. There's no perfect way, and it is going to be different for everybody's farm, for everybody's land, for everybody's crop history. Just keep plugging away at it. Ask lots of questions. Talk to other people around you, your peers, your people that work for your trusted advisors, your agronomists. Figure out what works locally. Don't just believe what gets marketed to you on a pamphlet and say this mix is amazing and it does all this and it guarantees you 20% yield improvements. You guys are all smarter than that. So figure things out and try things yourself and play with them and see what works. And talk to your local community. Figure out who's trying different things and make sure that if something didn't work, that was still worth doing, because then it tells you how to fix it the next time, or don't bother doing that anymore and we'll move on to something else. So we have to be not afraid. Tell each other what works, but be sure to tell each other what didn't work too, right? So a big thing for PEI is reducing erosion and tillage as much as possible, because every time you get erosion, you're losing your best soil, right? You're losing your top profile, you're losing your most organic matter in your soil is always at the top of your soil profile. So we want to really focus on reducing erosion, keeping that soil in the field, and maximizing that green cover and living roots for as many weeks as possible. You can have all the trash and all the residue you want. It's going to take a long time for that to move the needle on organic matter. But if you can keep your field green as much as possible, that's what's going to start moving the needle on organic matter. It's not a surprise that the highest organic matter fields are always Buddy's pasture field out behind the barn that gets manure on it every year and hasn't been worked in 10 years. There's lots of reasons why that one's 6% organic matter and the other fields are 3%. So that we learn from those things and we figure it out, it makes sense. And my pasture field next to the barn that gets grazed down to a putting green every 3 times every summer still is 6% organic matter, and I have hay fields that are 3.5 that I would think are better fields. It's because they never get worked. They are green all the time, so there's a lot to be said for that. So you can't replicate that in every rotation in every system, so just how do we maximize our green roots as much as possible and do what we can. So that's getting experimental with cover crops, cropping dynamics of planting winter covers after harvested crops, that winter crops that you can harvest that aren't just non-economical. So I know lots of you are probably growing winter wheat. We're seeing more winter wheat grown at home, but we're also experimenting with some of these other crops. Some people are talking about winter canola, trying to grow a market for winter rye. Right now it's fairly cheap cattle feed, but how do we grow it into something? I mean, they make a lot of rye whiskey out of Manitoba. Maybe we can make it in PEI, I don't know. But so far we're not. So yeah, what can we do to build resiliency in our whole industry? I just want to take 2 seconds to thank all our partners. This isn't just a potato board story. We do a lot of work with Ag Canada, both through the Living Labs program, through additional projects, the OFCAF program. PEI, it's administered by the Federation of Agriculture. I sit on one of their committees for reviewing projects, and it's a very, I really like working on that project with them. And then of course our PEI Department of Agriculture, you guys talked about the soil test lab, or the soil lab test that PEI has developed and implemented. And right now that's still free for all farmers. It's not going to be free forever, but at the moment it's free. I do every field on my farm at home at least once per rotation with that test to kind of benchmark and see where we're at, and hopefully we'll keep doing it. And then some of our other research partners, like East Prince Agri-Environment Committee, or Association, sorry. They're a group of farmers who are working on environmental projects, mostly potato farmers, and they are the deliverers of and organizers of the Living Labs project at PEI that I work on with them. A bunch of my research funding comes in partnership with Cavendish Farms and the growers themselves and the Department of Ag. And then Dalhousie, of course, work with Dave and work with a bunch of different people at a project with Dr. Lynch last year too, and a few different things. So yeah, working with lots of people at AC, UPEI, and the Fruit and Vegetable Growers of Canada. And of course the growers. None of my projects happen if it isn't for interested growers. So that's how to get a hold of me. If you have any questions, I can take some questions if I have time. I don't know if I've gone over my time, but I can take a question or two, or you can shoot me a text or a note that way. Any questions? Everybody's asleep.
That's okay. We'll have some time to ask you
All right.
right away.
I'm going to be here.
Yeah, great.
Okay. All right, we will get started. We have about 45 minutes or so till 2, so we have about 4 or 5 questions for these guys, and then we'll finish at 2. So first, I mean, you guys have already met Brian from PEI. I wanted to get him on this panel, basically to have that PEI perspective, I guess. I've spent a lot of time on farms in PEI, and they seem to talk about soil health like it's their second child. Like I can ask them so many other questions, but they always come back to their soil health. So it was just really, it was really great to get Brian here so that he could bring some of that perspective. We got Phil Keddy from Keddy Farms. Phil also is a good big soil health advocate, so we wanted to get him with his Nova Scotia knowledge. And then we got Thomas Harrington from Bragg Lumber, also. Again, other farms that when we were doing soil testing, Ariana also mentioned, okay, these guys have got this dialed in as well, so.
We had them for a while, you stole them back.
Belongs to Nova Scotia. Okay. All right, so question 1. We're going to go, we just talked about a lot of cover cropping practices, but we'll ask how have your cover crop practices evolved over the years, and what impact have they had on soil health and your farm productivity? So I think Brian kind of went through a couple of this. Brian, you can kind of talk to your own farm and what you guys have done personally, right?
Yeah, so since I started doing a bit more of this in my research job with my potato board hat on our home farm, so we milk about 80, 85 cows and also have some beef cows, do a little bit of cash cropping. And we've moved more towards, like, we try and get covers on all of our silage corn acres. Most years we would get it off between the 20th and 30th of September. So we usually have enough time to get a, like, fall rye or something on after that. And that's usually just gonna be a burn down crop for next year, but it's something to get the ground covered, something to build a little biomass. And one year when it was, like, 2020 was a really dry year, and we were short on feed. So some of the rye that we planted, we actually took off as round bale silage in like late May, and then we planted corn into that, and it ended up being our best corn field of that year. So, so we've been kind of playing around with it a little bit on the corn acres. I usually try and, any of our barley that isn't underseeded, we underseed most of it, but anything that isn't underseeded, I'll try and get a cheap cover on something there. And then we try and do rye after all the potatoes. We don't grow potatoes ourselves. We rent out about 40 or 50 acres to a potato grower, and we try and get rye on after those as much as we can, because that's the most vulnerable land. So that's kind of how we've changed things.
Yeah, our farm, I think this is our 48th year farming, and I'll call my father a traditionalist. He learned from somebody before him, and I learned a lot from him, but for 35 of the 47 years, we were, 3-year rotation growing our strawberry plants and then a grain cereal, and then we would always have a fallow. We'd try to grow some sort of green manure, which was mostly cereal rye at the time, plow it in and work the land for the strawberries the next year. And, we thought that was the best. We were giving the land a break, and getting it ready for the crop the next year. And then when I came back from university, he gave me a little bit of free rein, and I think I ran wild with it, with all the changes that we've made. But I think and I can show you some of the pictures, we're in a whole different place than we were back then. We were very traditional. We were fumigating all of our acres, basically killing everything back to sterile, and then moving forward from there. So there's broadband fumigation at its finest. Oh, right there. Yeah, we were fumigating solid fields, sterile, starting from there, and then trying to build everything back with fertility and spray programs. We haven't fumigated now in 5 years, and we see and we've tested it rigorously. We see no difference now in our practices than this. We lost a lot of the products we were using, but through good practices of mustards and the other things that we've added, we're seeing excellent control. Just up in the picture. So that there was our rye. We thought, geez, you get 5 feet of rye, plow that in, look at the great things we're doing. And we've rethought a lot of that. We hardly plow anymore. Just keep on flipping along here. So we said, okay, we're not going to plow, we're going to harrow. We bought this fancy tillage machine. That worked great until the grain on the top of the ground dried out and turned into straw, and then we had to muck around with that the rest of the year, so we don't do that anymore. And then that's what we would want in the fall for cover. That's a cereal rye going into fall, that we're going to spray that out at that point, and then that's a perfect seeding bed. So that was always one thing we were trying to achieve. Going into fall, have your land ready for whatever crop you're going to plant next year, and then put rye on it, terminate it at 4 or 5 inches to hold the ground in place through the winter, and have something there. So, that's one of that's kind of the direction we always went. And then we added, so back to your point about simple, keep it simple. So we already had the harrow, so we added an air seeder on the back. And that's when we started having the ability to fool around with multiple mixes. I think I've tried every cover crop under the sun. So this is a 1-pass machine right behind the combine, seeding at the same time, and then you'll see the results there now. I'm just going to fire through all these quickly.
Yep, go ahead.
So there was a 3-way mix: clover, Italian rye, and tillage radish. We were very pleased with that, so we kept kind of moving in that direction. Then we started, there's more of that. Then we started mowing it for silage. So we were taking out hay fields and taking our cover crops, turning them into cattle feed, letting it regrow, and then prep the soil for the high value crop in the next year, which that was going pretty good. But more often than not, we're running into dry weather, and in the dry weather, trying to do all of your prep tillage, it was just not working anymore. So we went away from that, and now that was a cereal rye terminated 1st of May, 1st of May, and now we're no-tilling mustard into a cereal rye field that will be biofumate. There it is, a few weeks later. Click one more. So this is where we're at now. So we've gone to a cover crop for the fall. We've gone to a no-till mustard into that cover crop. We've gone to a one-pass biofumigant. So there's a big mulcher on the front of that tractor. There's a harrow in the back, and that has a packing roller. So we're mowing, incorporating, and packing all in one pass. And with this practice, we're seeing as good a control as our original soil fumigants. We've done this for 2 or 3 years in testing to have fumigant next to mustard. We've tested side by side, back to back. I didn't see the value in going any forward with the fumigants now. Will our customers ask us in the future to go back to that? Possibly. But as long as our plants can perform as good as our competitors with a chemical version, then they're not going to question my practices. So then now we're working that mustard in. We're adding our lime, our gypsum. We're subsoiling and chiseling, getting everything ready for the next spring. And now instead of a fall rye, I'm going back in with a fall mustard. So that's mustard on the 1st November that was seeded early mid-September. And winter is terminating that now for me, so I don't need Roundup anymore. Winter terminates that. I got a crispy layer that is easily incorporated in the spring, and my transplanters will work through it. We're getting near the end.
Yep.
This is just some other stuff I tried. There's buckwheat, 4-week-old buckwheat, standing and incorporated in with that same harrow. So if we're adding in if we have a field that we don't know what we want to do with it, we'll throw buckwheat on there and incorporate that in. That's worked well. And there should be one more. And this is all the other stuff that's Austrian pea up in the top left, that's crimson clover in the bottom left. Sudan grass, we're using a lot of that now in our rotation for cattle feed, but also it's a good cover, it terminates in the winter. And a year ago we did marigolds. We had 3 acres of marigolds. And I love the concept, I love what it did. It is about the most miserable thing you could think to seed. So we haven't got the simplicity down yet, how we're going to plant it, because it's a long porcupine quill that doesn't do well in grain drills, air seeders. So once I figure that out, I'm heading in that direction, because it was 5 feet tall, it blossomed right till late fall, and when we flail mowed that and harrowed that in, it almost burned her up there. You could just smell the power. So we were pleased with what we were getting out of that.
Marigolds are great for nematodes.
Yeah, and those were biofumigant marigolds that we tracked down a variety. So they were tall and thick, and there was hardly any, you could almost see the weed suppression happening within the canopy. When you move the canopy, you could see weed suppression, and when you worked them in, you could tell something was happening. So we were happy. So that's just kind of all my pictures you can ask. So from where we started to where we are now, and are we done? No. Right now we're moving in the direction of I call it traffic farming, where we're ripping and then never putting a tractor wheel back over that rip mark with a power harrow and planting over that rip mark, because our crop drainage is key. Strawberry plants absolutely hate water and wet feet, and root rot is the one thing that will kill them very easily. So we're moving in the direction with this now into traffic farming and trying to eliminate all those problems.
Right. Oh, we need more?
Hello everyone. I don't have any fancy pictures for you like Phil, but I'm trying to give you a little history. So Bragg Lumber, we grow processing carrots. We're part of the Oxford Frozen Food Group, so all of our carrots go to Oxford for freezing. So carrots, similar to potatoes, fall harvest crop, so cover cropping can be a little bit challenging. So really, over the years, evolved from virtually no sort of cover after carrots, so that evolved into bale busting, things like that to try to prevent the erosion. Cereal rye has been broadcast after carrots for quite a few decades now, so that's sort of been the standard practice. Really, I kind of look at our cover cropping as in sort of 3 different phases. Phase 1 was really just how do we stop it from getting worse? How do we prevent any soil erosion? How do we stop deterioration of the soil? Sort of phase 2 is actually how can we start making this better? And so we really got into cover crops to target specific issues. So brown mustard for sorghum stand, try to build organic matter. And I would say now we're sort of in the third phase where we're trying to do a lot of different things at once and experimenting and things like that, but we're trying to incorporate cover crops, not just for soil health, but more, environmental health. So we have apiary in the valley as well. So a lot of our cover crop mixes we're putting in flowers in there as well to try to promote our own pollinators as well as wild pollinators as well. So yeah.
Awesome, perfect. Anybody have questions about the cover crops? Cover crops? No? Come on, guys.
Wrapped up in it.
Yeah, there we go. Anything, cover crops? Nope? Okay. We will move along to production practices. They already kind of talked about a few of these, but what sustainable practices are you using and what challenges and benefits have you experienced?
So, potato board hat on, I would say we've had a big move, as I mentioned, towards, let's say, reduced tillage, or minimal tillage or residue tillage in potatoes and PEI. I'd say well over half the acres are now in that, probably almost 2/3 of the acres now are in sort of that vertical till as opposed to moldboard. And definitely more cover cropping happening, some changes in rotation like I talked about, is that trying to optimize that all the time. At home, we're now planting all the corn with no-till drills. We got a no-till drill about 4 or 5 years ago. As I said, trying to do more cover cropping. We have a fairly long rotation home. Most of our, where we have potatoes, it's usually in about a 6-year rotation. So it's usually potatoes, then corn, then barley, then usually 3 years alfalfa. Don't know that we can lengthen it too much. I don't think we need to lengthen it too much, but that seems to be doing a pretty good job. And then we're kind of trying to up our game a little bit too on the rotational grazing. So we have a lot of fields where we just used to turn the cows out a little bit, or we didn't manage them too intensely. Trying to have shorter, we're trying to increase stocking density for shorter periods of time on different fields, putting a few more paddocks in on the dairy cows, and then giving them enough time to recover and then going back in there again. We have a few fields where it grows so fast in the spring we can't keep on top of fast enough, so we have a few fields that we take the first cut off as silage, and then we will try and get at least 2 grazes out of them in the summer. So some of the stuff that's close to the farm. I want to do a better job with grazing our beef cattle, but the beef cattle are always the last thing to spend time and money on at our farm. So we have a 100-acre block up the road that's not really good for anything else except growing cheap beef cattle with pasture. So they just kind of get turned out in the 3 blocks there. My next goal is to break that up into more paddocks, get some more watering systems in, and use that pasture ground a little more efficiently.
Yeah, I guess, tillage was always our biggest challenge. We love, by using a lot of tillage, we were killing weeds, and we thought we were doing the best getting the soil ready for the next year. But by changing our pieces of equipment around and how we're doing things, we have drastically reduced our tillage, and I feel that we're getting a better soil health out of that. It's not beat down in the spring, and makes me feel better knowing that I'm not releasing carbon every time I'm out there with the disc arrow, I guess. So our tillage practices have wildly changed and not sacrificed the land quality in the spring of what we're planting into. So by using cover crops that are naturally burnt, dying in the winter, and there's minimal residue in the spring, we don't need extra passes in the spring to get rid of that residue. It's already crumbled up and allowed us to go that way. Water usage is another one, kind of through drip irrigation sprinklers, but we've always paid I said lime is the cheapest thing. A soil sample is the cheapest thing a farmer can invest in, because every 3 years, everything is soil sample. We want our pH dead in range, because if you're out of range, you may be applying all that fertilizer, but your plants aren't getting half it because it's tied up, and we work closely with Sunny on analyzing our soil samples. Okay, are we going with calisthenic lime or dolomite lime? Are we going in there with gypsum? That we make more money back on having our soil in line with our soil samples then, and I just shake my head at people, I don't know what the pH of that field is. Oh my God, I wouldn't, if you're a horticultural grower and you have no idea what you're starting with, I know the consequences of that. So like that's where we pay a lot of attention into, and I know we've gone in the direction now of starting to use gypsum as tying up. In some of our fields, we're using gypsum to tie up the particles and make it more airable, and just whatever we can to move the bar in the soil health range is kind of where we're at.
Yeah, and just to echo what Ryan and Phil said as well, we soil sample everything before it goes into carrots every cycle, every acre, and then we follow that up through the season with the tissue sampling through most of our fields just to make sure that the crop is getting everything that it needs. So we're trying to really optimize our fertility there, and our tillage as well. We've really changed that over the years, really reducing passes, getting some new equipment that is a little more efficient. A lot of the veg prep used to be a lot of moldboard plowing, disking, and chisel plowing, and really we've gotten away from that into more sort of high-speed discs that you can do a lot more tillage, a lot more efficient tillage in one pass, that sort of thing. And it is hard with a crop like carrots, where if you ever tried to seed them by hand in your own garden, you know how small they are. So you need to have enough breakdown of the soil that we can get good germination, but not too much. So I feel like we're trying to really get that dialed in. And like Ryan mentioned in his presentation, in potatoes we've experimented a bit with fall ridging in carrots with some success. So we're doing a fair bit of that now, where we'll ridge out the soil in September or late August and plant brown mustard in between the rows, and it'll get up. Not too tall to interfere with seeding the next spring, but it'll get up and sort of winter kill out, and then we can go in and just, we only have to do a tiny little bit of strip freshening, we call it, on the top of the ridges, and then we can seed carrots directly into that. So that's been an interesting experiment for us too.
Nice. Okay, so I think we've got reduced tillage, we've got soil testing regularly, plant tissue testing, rotation, intercropping little. Okay, that's great. Actually, I think that this is one of your fields, Thomas, now that I'm looking at it. One of the last ones we took over. And great. Yes. Yeah. Colchester. Any questions on? Oh, Amy. More, are they composite soil samples you're doing, or are you getting into more precision?
Well, they're composite. Over the last few years, I've done some of that precision, and you get a stack of, here's 26 layers of maps, and I look at it and I'm like, how am I easily and practically going to apply that on a field for basis? Like, am I going to, like, we're not quite there yet where we want to invest the big money into, okay, the fertilizer spreader, and we're there, I mean, we could, but the fertilizer spreader could stop 100 feet up the field, leave 100 feet, and then turn back on. We have the capability and we have the equipment, but with the high value crop and things, we're just not quite wanting to. What's that?
You don't have the heart.
I don't have the heart. Listen, when I hire myself another me, so I guess let's put it that way. I'm overwhelmed with what I'm doing on the farm, and when I find another me to replace me, we will gladly move in that direction.
We're not doing anything site-specific at the home farm, because my biggest field is 20 acres. And I took some growers over to Belgium on a tour last year. We were going to potato farms and on one of my committees over there. And we went to these farms, and we asked people, what are you doing on precision ag and on, GPS and stuff? It's like, oh yeah, we got GPS in the tractors now. And it was like, that was where they were, which is where we were 15 years ago. But they weren't doing any GPS soil sampling or any precision ag, site-specific management. Why? Because all the fields were 3 acres. So it was like there wasn't enough variability within field to worry about it. So at home, I know I have fields that are variable from top to bottom, especially my shorter fields. Like we're on Maltec Bay. I got my short fields are sand, like there's sand here towards the end. I know there's differences, but like the payback on our size of farm right now isn't there to justify the change. It's the next step, like GPS on all the tractors now. There's like we're gonna move in that direction, but it's gonna be a slow picking away.
Yeah, and I would say we still composite sample all of our fields, but the majority of our land we have had mapped through the SWOT map system. Started to do a little bit of variable rate through it. Our kind of stance on it is we're getting everything mapped, and when we're ready to really sort of jump into it, we're ready to go. It's not that like this field's ready and this one's not. We'll let the whole acreage is ready to go. And to your point, Amy, it is a logistical challenge, especially if you contract out that to other services. And if the mapping services is provided by somebody who's not doing the spreading, then where are you involved in that process? So it's something we're working through, and it's actually gone fairly smoothly when we have done variable rate applications. And I can see in the next couple of years it's something that will probably make our standard practice.
And I would just add for the potato guys I work for, a lot of those guys are like site-specific corner to corner in terms of like variable rate lime, variable rate potash particularly. That's where the dollar savings tends to be. But we also have some guys that are into variable rate seed spacing on the potatoes. Like so now a lot of the newer planters have the ability to do variable rate seed spacing that they didn't used to. And so we had a project through our program with a PhD student at UPEI, and he was able to show that, especially the good parts of your field, like if you're doing SWOT mapping, those like really good zones of the field where you can tighten your seed spacing up a little bit. Tightening the seed spacing by 15%, I think increased, payout by $300 or $400 an acre. So, that made it worthwhile doing. Like if you're saving $10 and $15 there, you're trading money for doing soil samples and things. But if you're saving $100 and $200 an acre, then the value proposition starts coming together real quick.
I had one more now that I had some time to think about that. And I'm sure a lot of you will be able to relate to this. When you are in specialized horticulture, most of that fancy equipment doesn't fit our farms. We side dress a huge amount of our fertility, and most of our equipment we had to make or modify, and that side of the industry has not caught up yet to, yeah, sure, I could hire somebody to do variable rate, but that's not how I want to apply all of my nutrients. I want to side dress it right in. I want to split it 4 to 5 times through the season so it's not lost through big rains. And that side of the equipment market hasn't really caught up to the needs of our farm and probably a lot of other specialized horticulture. So.
Okay, did that, oh, Rosa?
I got a follow-up question, because Amy and I have been
Okay.
Bill talked about how important lime is in wood production, and obviously said you've done a lot of SWOT mapping. Can you speak to how variable you need
The question, Rosie, was on the SWOT maps, how much variability was there in pH? It could be quite a bit. Yeah, like some fields it would be 4, like 4.5, and but I mean, you do have to go back and look at the maps. Maybe that is just a small, tiny little corner that you do have to realize that maybe you're not going to farm that piece anyways or something like that. But yeah, it is pretty interesting looking at it. And a lot of it makes sense. Like when you do see the zones and you actually go and visit the field and walk it, it seems to reflect sort of what's going on intuitively, I think, when you're basically looking at the crop.
All right, next question. I think we maybe already answered some of this, but has your soil health practices changed yield or productivity? How did you better measure the success in the short and long term?
So I covered a little bit of this in my presentation, but sometimes it's really hard to measure short soil health like changes in the short term, and sometimes you only see it in the bad year. So I like to look at, there's two case studies 2001 and 2020 were the two driest years in PEI in the last 50 years. 2001, when no cover crops were getting planted, and when like it was a pretty old school way of doing things, and we were also growing way too many potatoes in every spare corner of potatoes you grow them in. It was a crop failure year, and the average yield was about 200 hundredweight, and it was not a good scene. And 2020, we had less rainfall than in 2001. After growers are doing more cover cropping and better land management and that sort of thing, on average, like we had a yield reduction, but the yield reduction was like the average yield was about 260 instead of 200. And so there's lots of things in there. There's varieties in there. There's lots. You can't pin anything on one thing. But I think the collective works that the growers are doing in terms of looking after their soil and reducing soil erosion and cover cropping and improved rotations, I think that is having an effect. I think it's getting them through those little dry periods a little bit longer. If it stays dry for 6 weeks, no amount of organic matter and cover cropping is going to do much. But if you can get it through a little bit longer and hope that you can get it to the next rain, and those fields with your better organic matter last year, like stopped raining in most of PEI the last week of July, and a lot of people didn't get rain of any amount until September. And the higher organic matter fields consistently were 40, 50, 60 hundredweight better than the poor, sandy, low organic matter fields. So I saw that in my own trials. So, there definitely is value in that. But if you only measure it on the good years, a lot of times you just say, oh, well, it's not that much difference. But yeah, I think on those poor years, especially in a system where you're not irrigating, I think it makes a difference.
Yeah, it's hard to measure because it is a year by year kind of thing, and I mean we're in a 4-year rotation, so I'm old enough now to say I've seen enough of the same crop over 4 years, going back enough years, that I get a feel for what the yield should be, and we're achieving things now on some of the fields that were almost a write-off years ago, and whether it was the soils were, I guess we're trying to learn more about our soils, but we're looking at gypsum a lot more because we've got soils that will work it up and it'll be the most beautiful sand, but then after 2 or 3 hard rains, it's hard and it binds, and then you got no drainage, and the plants just do horrible. So we're looking at things like gypsum and changing things to try to free that soil up and get drainage happening. And so we're seeing things like that. And at the end of the day, when we travel, I mean, our plants all go to Florida. We were just down there last week, and when you're in a 500-acre field and there's 10 different growers from all over North America, and they point at yours and say, look, very few of yours died. They picked 10 flats more to the acre than your competitors. You just compare against all your competition, and that speaks highly that we're doing something right on my end, and I couldn't tell you what it is, but it makes me feel good at the end of the day that this time and money and all this investment into changing the farm in this direction is slowly paying off. So.
Yeah, and I'd say the same, that we feel that we're in it for the long term, and a lot of these things are not a direct one-to-one, do this yield's going to be better this year every year, but we know that a lot of these practices are beneficial and we're going to keep doing them. Interesting thing on our farm is that we do farm in the valley as well as Colchester, and the Colchester land block is in a totally different rotation. There's no other veg grown on those fields, so it's predominantly in a no-till corn, soy, wheat rotation, and we have done some soil health testing a couple years ago. We picked 12 of our fields in our different areas and did soil health testing, and it was really surprising. Those fields in Colchester had top marks on all the soil health tests compared to some of our other land that had been maybe rotated a little bit more intensively in the valley. So yeah, that soil health testing is something that we've committed to doing once every rotation in our care rotation, so that we'll go back, resample those fields all again in 12 years and try to develop our own benchmarks, I guess, as well as do the work that NS is doing as well to try to figure out what numbers should we be looking for, what's good, what's bad, where do we want to go. But that's we decided to start somewhere and do our own sort of benchmarking and go from there.
Great.
Man's present here.
Okay, two quick last questions. We've also talked about seasonality, decision making, does the seasonality, weather, I mean, there's been rapid change in weather in short periods of time in the last couple of years. How do you guys make those decisions based on soil health or production strategies? I know we talked a lot about those late crops, getting on cut crops. Like, how do you make those decisions in a quick, short time?
Yeah, I like what Phil was saying about trying to have the ground be ready for next year's crop in the fall and tailoring your cover crop strategy around that. So that's why ahead of potatoes, most guys I'm working with are growing just something that's going to winter kill, and then it'll winter kill once there's snow on it, if we have good snow, and then it'll be ready to rock in the spring. We do have some people, especially in the east, where there's a little less snow, a little more early thaw, maybe trying to do more with winter cereals to hold the ground better, and then spray it out in the spring. But it's, a lot of this stuff you only learn by trial and error too. Like, I have some guys that, absolutely love working with rye, and then some guys hate it because they just I look at it and it's not ready, and then I look at it a week later and it's in head, and I don't know why, I can't get it timed, it goes too fast. So I say to those guys, grow winter wheat, and just don't plan on harvesting, but it's going to be easier to kill than rye. And it, if it fits, if you got a wet field, don't put winter rye in it because you might not be able to get on it, get sprayed out or whatever. So it's about trying to be working around like what Mother Nature gives you, I guess. But I think at least at home, the falls are getting longer, and we're getting more and more establishment later. So it's more opportunity for getting covers on later, and just trying to optimize the tillage. The problem last year was that all these guys that had been used to doing their primary tillage in the last week of August, 1st of September, and it was so dry they couldn't get the residue till machines into the field. So then that put them back a couple of weeks, which then put back their cover crop establishment. So it wasn't great. So you just got to do the best you can, I guess, is basically what it is. Just do whatever you can do to be successful, but don't worry, sometimes it doesn't all come out according to plan.
Yeah, I guess I'll kind of say the same thing. Like, I've already ordered all my cover crop seeds now for this upcoming season, and if things may change, and I'll make some different decisions, and I'm not scared to let it sit in the bag and all next year. If it's a late fall and it's cooling off, then I might not go there with mustards. And I always keep about 8 tons of cereal rye cleaned. I clean it so there's no weeds in it as my backup cover crop. I've seeded that stuff the 1st November, and it just gets established enough with roots to hold it in the ground. Like, cereal rye is about the most forgiving thing. If you want to start somewhere, cereal rye, you can't kill it. It'll
bulletproof.
Yeah, plant it 1st November and you'll get something, but that's our fallback. So I always have cereal rye sitting there as my fallback. If it's too wet, I can't put my mustards in, or the temperatures are cooling off and I'm not going to get a good establishment, we just go there with cereal rye. At least we have our backup plan.
There you go.
Yeah, obviously the backup. Try your best. Yeah, and like the others said, we really try to do as much prep in when we have the opportunity when the weather is good to prepare for next season's crop. So we do try to have a cover crop going into carrots, and we can do a lot of our slow prep. Really try to do a lot of our subsoiling or compaction mitigation when it is dry, so you don't get in there when it's wet and making a mess, and recompacting, that sort of thing. So yeah, we really try to think about why you're doing something instead of get stuck on it has to be done at a certain time of year for this certain reason. Maybe that field doesn't get subsoil late in the fall because it got too wet. Maybe you have an opportunity in the spring or something like that. And yeah, just try our best.
Great. Okay. And one last question. There we go. Goals for the future. What are your short and long-term goals for improving production practices, sustainability? What would your ideal practices in improving methods look like?
Well, it's hard to give goals for an entire industry, so I'm not going to. I would particularly like to see, for the potato industry, I would like to see, right now we're about 60% covers ahead of potatoes. I'd love to see that up over 80-85%. We're at about 55-ish% on covers after potatoes. I'd love to see it up over 75 or so. We've seen a lot of movement away from some of the old long season varieties, like anybody knows Russell Burbanks, that are, you know, you can dig them on Halloween. We're moving away from those varieties towards more shorter season varieties, so I think that's a definite goal. And then I have a lot of guys that want to get their organic matters up, so we're working on that. And on our home farm, I've put a big focus on certain fields that maybe had been in the shorter rotations where the organic matters have gotten a little lower than I wanted. I'm trying to be focused on our use of organic amendments and you know, max covers and a few other things to try and get some of those organic matters back up so that they'll just carry a little better in the summertime, carry the crop a little better in the summertime. Yeah, and then as I mentioned before, I want to do a little better with our grazing program. Just trying to, again, use our land a little bit better, be able to probably have more animals on the same land with a little better productivity. It's kind of the plan at the moment. So, say for the home farm, that's kind of the main thing.
Yeah, that's a pretty broad question. I mean, we're changing things all the time, but if I really had to think about it, I mean, given what we knew 30 years ago and you know, through smaller rotations because we didn't have the land base, you know, I think our organic matter has suffered from that. But now we've been able to purchase more land. We've got our rotation out for working on 5 years, better cover cropping. Ultimately, something like this came to the back of my mind. Me and my wife had to put a presentation together for outstanding young farmers, and we spent weeks working through this, typing up this huge presentation, and what came out of it is that we said one of our core values on our farm is going to be that we leave the soil in better shape for our children than we received it. So on a year-to-year basis, that's always in the back of our minds. What are we doing to better the soil so that my 2 kids will have they're going to have a soil that's full of life and fertility and be able to carry the farm onwards that way. So we don't think year to year, we're thinking way out, you know, how do we just make things better for the next generation?
Yeah, and Greg Lumber's really tried to take a farming for the future approach on all the farms, not just on the carrot farm, but on their wild blueberry operations as well. And part of that, we've had a goal to cover crop 20% of our land base every year, so we've kind of been sticking to that the last number of years. And like I said, not just farming for soil health, but also greater environmental health and ecosystem health with some of our pollinator carrots, things like that. Something we've done recently too is taking out, you know, small corners of land that are kind of tough to farm, or they're always that little acre you always struggle to get in because it's too wet. Just take that out of our annual cropping system and put in we kind of call them bloom yards, I guess, and so put them into perennial flowers, things like that. And on that note, taking out some other land from annual cropping system, putting it into forage, and we'll harvest that and use it as hay on our really late harvested fields that we can't get a cover crop put on for one reason or the other. We'll bale dust that to make sure that it does have at least some protection from erosion. And as well as it's just really trying to increase our harvest efficiency too, so we aren't in that situation where if it's getting late in the year, we can really get all of our harvests and crews going together and put that push on, so we're hopefully not in that really late November window where you're just struggling to get everything in the ground, let alone the cover crop in. So yeah, that's just kind of a few things for you. And as I mentioned, the soil health testing, which is kind of part of our longer term goals, I guess, is how do we put some numbers and metrics to what we're actually doing.
I had one final comment.
Go right ahead.
I love to talk, and we've been talking cover crops for quite a few years now, and the one thing I've noticed that people always say is, how do you afford it? How do you take a field out of production and cover crop it and do the right things, because it's not going to make $1. And I tell most people, you're thinking about it the wrong way. By what you're investing in that year that you're taking it out and cover cropping it, you're going to gain it in the next year in your higher value crop. And that's how you have to justify and feel good about it, is that it does pay off, but it's not going to pay off that year. You're going to see it in the crop that's actually going to pay the bills. And you got to think about it in that term, because it is not cheap. some of these cover crops things that we're doing, but it is paying off in the years that it needs to, so.
I've got a few trials actually on that exact thing where we've got, 3-year rotation, 3 cash crops, 2 cash crops, and then potatoes is the only cash crop side by side. And a bunch of those are going into potatoes this year and next year. And yeah, it's about, we can frig around trying to make $100 on barley or wheat, or we could try and make $500 on a potato crop. And that's in some cases where the, trying to make the juice worth the squeeze. So that's what we're trying to do.
Perfect. I like that. Make it choose with the squeeze. Okay. All right. Is there any other questions, final questions for these guys? Anything they brought up? I think they're pretty thorough. No questions? You guys did such a great job.
You guys
Oh, we do
notice,
have one. Okay, yes.
you guys notice any difference between covers that you harvest and then till in versus covers that you allow to grow to maturity and then incorporate into the ground? Is there more value in cover crops that you can harvest versus others that you just directly till?
It depends. So I mentioned we had variable success with like the mustards with the biofumigation, but again, it's different if you're trying to do something on 50 acres or 100 acres and you can time it perfectly and you can do the right job on it, or you're trying to do something on 1,000 acres. So if you're trying to do something on 100 acres and you can time it right, you can time your planting, and you've got access to water and things like that, I have seen that work really well. And same with things like buckwheat and for wireworm prevention or mitigation. I have seen it work really well. But a lot of the other covers, I don't know that there's a lot more benefit of green manuring it in as opposed to, say, mowing it off and doing your incorporation later and putting in another crop or something. Again, it depends on your rotation a bit and how things are optimized, but I would say definitely if you're getting into that, I would want to do a little bit of side-by-side stuff at home and really focus on doing, like, pick your worst field, doing your worst field first, and then kind of go from there.
It'll give you the most benefit.
Yeah.
And it's all on timing. We've taken Sedan grass. We said, holy geez, look how big this 10 feet high. And tried to disc it in, and what a nightmare. Oh, we couldn't mow it, we couldn't plow, we couldn't do it. So we said, no, we're not going to do that again. But what a heck of a bio crop that we put back in. But it took 2 years to get that field back to where we could actually work with it properly. And then we more or less learned by mowing it more often, you're stimulating more root growth and going after the nematodes that you're after anyway. So, I used to be the old mentality, the more stuff I'm plowing into the soil, that's the best thing I can do, but I'm not so sure that's true anymore, because it takes more nitrogen to break that down.
It was expensive to do that.
Yeah, so I'm thinking, mowing or go in there, get a crop established, work it in, put another one in behind it with a no-till drill. Reduce your tillage, but get multiple. Like I said, we're up to 3 cover crops in the run of a year now. We're carrying one over in the winter, we're putting a mustard, we're doing our prep, and then we're putting another mustard in, so, we're kind of going that direction. Things can get out of hand really quick.
Just to add real briefly on the Sedan grass, we found the same thing. You got more benefit by mowing it more frequently and multiplying. Like your root mass almost doubles the first time you cut it, but you can't cut it too low. So you got to leave it about a foot and then let it regrow. And if you're really worried about nematodes, I would try pearl millet instead of Sedan grass. Like forage pearl millet, it looks almost exactly the same in the field, and it grows similar, same planting date, same management, same fertility, but it's specifically it's a non-host for most nematodes, so it's a good option as well.
Yeah, I was just going to add that the brown mustard for us is really the only one that gets worked in season. Everything else we mow it a couple times and just try not to till that until it's ready to be prepped for carrots.
If you are using Sedan grass, so we've started using Sedan grass for our cattle, they like it shorter and tender. So that's why we started mowing it. We mow it 2 or 3 times. And we set our mower up there 6 inches up off the ground, and it'll regrow. And that system's working really good. The cows absolutely love it as feed quality. So.
Is that it? Or do we have anything else? Good? Okay. I think I just learned learned in 4 hours, more than I learned in many years of college and university. Okay, can I get a hand